This is Anton Semchenko and I'm gonna be your tutor for the Unity game development in 4 hours course. I will introduce you to one of the most popular tools in the game development industry. Before we begin, let me introduce myself. I've been using Unity 3D for 7 years on a daily basis. I worked on many projects including 2D, 3D and VR games and AR apps. So far, I have shipped 2 games for PC, and one of them was released on PlayStation 4 as well. The first game is called Fabric. It is a puzzle game played in first-person perspective with a unique space-bending mechanic. The second game is Alchemist's Castle. It is a 2D side-scroller platformer with light Metroidvania elements and emphasis on exploration. Alchemist's Castle won 2 awards so far, the Best Game Design Award and the Best Game Award. If you are curious about my other projects or just want to say hi, follow me on Twitter at @theantonsem. Also, you can check my webpage. It is anton.website. And now let's take a look at the outline for this course. First, I will walk you through the installation process of the required software. This will be the most boring and straightforward part of this tutorial. Then, I will show you Unity's interface. In the second part, I will explain what the game object and component means in the Unity's context. You will learn how to create and save them, and we will take a look at a couple of the most used components in Unity. Finally, I will show you how to use a pre-made first-person controller to walk around the environment you will be creating. In the following section, we will discuss the basic level building techniques and tools. By the end of it, we will have an outline for our first level. Next, I will show you how to utilize Unity's asset store and where to find free assets for your game. Using these assets, we will finalize the design of our level. The fifth section will be the most complicated part of this project. We will write some code for the basic logic of the game and make it work. By the end of this section, we will have a fully functional game on our hands. Then we will proceed to the UI system. We are gonna need it to communicate the critical information to our player. In the 7th and the final section, we will talk about polishing, what it means, and how the lack of it can break your game. By the end of this course, you will have a very similar game to the one you are seeing on the screen right now. If you wish, you can continue to work on it using the knowledge you have acquired throughout this course and make a fully featured story-driven experience out of it. Or you can just release this short experience as it is. For this course, you're gonna need a PC with Microsoft Windows, macOS or Linux installed. I will be using Windows myself. Unity fully supports macOS but has only partial and very limited support for Linux systems. So keep that in mind if you are a Linux user. Before we begin, I will talk you through the Unity installation process. Visual Studio is not required but highly suggested. It will make writing code much easier. I will assume that you have some basic C# knowledge. We are not gonna be writing any advanced code, but knowing what a method or a variable means will help you to understand what we are doing. And finally, the 2 most important things that you are gonna need will be imagination and determination. Developing game is not always fun, and you will be stuck quite a lot. Knowing your goal and focusing on it will help you get motivated during those times. And without further ado, let's get started. Welcome back. Good to see that you are still here. In the introduction video, I promised to walk you through the installation process of Unity and Visual Studio. So let's begin. To download the Unity, go to unity3d.com and click Get Started. On the next page, you will see 3 options: Plus, Pro and Personal. You don't have to worry about Plus and Pro unless you or your company generates revenue of $200,000 or more. And you don't get a different version of the engine with the subscriptions anyway. So just click on the Try Personal button and proceed to the next page. On this page, before downloading Unity, you will have to agree to the terms of service. Then you will see 2 options: Download installer for Windows or macOS if you are on Mac, and download Unity Hub. You can download the installer, but I suggest going with the Hub. It makes managing different versions of Unity and Unity components much easier. After downloading and installing Unity Hub as you would install any other software, run it and you should see a similar window. Of course, you won't have any projects just yet. At the top, you will see 3 tabs: Projects, Learn, and Installs. Currently, the Projects tab should be active. Click on the Installs tab. Here you can see all of the installed versions of Unity. Since you don't have any installed, this list should be empty as well. On the left side, you will see 3 sections: On My Machine, Official Releases, and Beta Releases. On My Machine is the current tab. In the Official Releases, you can see all of the stable and currently supported versions of the engine. As of time of this recording, Unity 2019.1 is still in beta. Click on the Beta Releases if it is still the case. For this course, we will be using Unity 2019.1.0b4. Click on the Download button and this window will pop up. Here you can choose extra components, like a support to get a build for a different system. For now, we're just gonna need the editor itself. You can always open this window and install the required component later on. Click Done and wait for the hub to download and install the engine. Now let's proceed to installing the Visual Studio. As I mentioned in the introduction video, using Visual Studio is not mandatory, but I suggest that you do. It makes writing code much easier and faster. To download it, go to visualstudio.microsoft.com and download Community 2017 version. It is a free version, but will be more than enough for the most of your needs. Run the file you just downloaded, and the first thing it will do is to download and install the Visual Studio installer. Then you are going to need to choose the components you would like to install. We will require only game development with Unity tools. So choose it, click Install, and wait for the Visual Studio to download and install. After the installation is complete, it will ask you to either sign in or create a new Microsoft account. It is not mandatory, but it will save your settings to the cloud if you do. And that is it for the installation process. In the next video, we will create a new project and take a look at the Unity's interface. See you then! So far, we have installed Unity and Visual Studio. In this video, I will walk you through the interface of Unity 2019.1. First, you will have to create a new project. So launch Unity Hub, and in the right top corner you will see a few buttons: New, Open, Settings, and Sign In. Since you don't have any projects yet, click New. Now you are going to need to set a folder to save a project and choose a name for your project. I will name my project as Awesome Packed Game, but you can name it whatever you like. To set the location in which you would like to save the project, click on these 3 dots and pick a folder. Next, you can choose a Unity version to run this project in. If you haven't installed any other versions, then you should see only the 2019.1. Below, there is a template field. All it does is preset some settings while creating the project, but you can change them later on anyway, so don't worry about it right now and choose 3D. Finally, we can add an asset package, but we don't need them just yet, and again, we can do it after we have created the project. Click the Create Project button and wait for Unity to set the things up. It might take a few minutes. After Unity opens up, you should see a similar layout. If anything seems overwhelming or unclear, don't worry. Everything will be much more obvious once you begin to actually work with the engine. First, let's take a look at the Scene tab. Usually, it is referred to as the Scene view. You should see it at the top of the middle window. Click to activate it. In this window, you can see and manipulate objects in your game. To select any object, just left-click on it. To look around, hold the right mouse button and move the mouse in the direction you would like to look. To move the camera left, right, up or down, hold the middle mouse button or the wheel and move the mouse. To zoom in, use the mouse wheel. Alternatively, with the Scene view focused on, you can use arrow keys to move around. Or click and hold the right button, use W, A, S and D keys to move forward, left, backward and right respectively. While holding the right mouse button, press E or Q to move up or down. Speed up the movement by holding the Shift key. Rotate the view around the point by holding Alt key, clicking and holding the left mouse button and moving the mouse around. At the right top corner of the Scene view, there is an axis indicator. It represents the current rotation of the camera with respect to X, Y, and Z axis. Click on any of the pointers to set the view to that specific angle. Click on this perspective text to change between the perspective and isometric views. You can do the same by clicking on the cube in the middle of the indicator. You can lock perspective by clicking on this little lock icon on the top right corner of the sim view. Notice how objects are getting highlighted in the hierarchy window when I click on them in the sim view. As the name suggests, this window represents the hierarchy of the scene. You can see all of the game objects and their relations to each other in this window. You can create or remove a game object from the scene using this window. We will go into more details in the next video. For now, I will just create a cube. Now let's take a look at the scene view again. Select the new cube from the hierarchy and click on the arrow button at the top left corner of the screen. You should see these arrows pointing out of the cube. Click on them and drag the cube in the respective direction. Also, you can click on these small planes between the arrows to move the cube on that specific plane. Holding the control button while dragging an object will move it by 1 unit at a time. Next, let's take a look at the rotation tool. The button for the tool is next to the move tool button. Click on it and you will see these colored circles around the cube. Click on any of them and move the mouse to rotate it in the respective direction. Similar to the moving tool, each color represents an axis of rotation. To rotate an object around the y-axis, use the green circle. To rotate around X and Z axis, use the red and blue circles respectively. You can freely rotate the cube on every axis just by clicking in the middle, but it is pretty hard to do it this way. Similar to the moving tool, holding Ctrl will rotate an object by 15 degrees. Let's move on to the scaling tool. Again, you can see the axis indicators. Manipulating them will change the scale of an object on that specific axis. Clicking in the middle and moving the mouse up, down, left or right will change the scale in all axes. Hold the control button to change the scale by 0.1 units at a time. Finally, if you click on this button, you will see all of the 3 controls at the same time. To quickly switch between them, you can use keyboard shortcuts. Press W to move, E to rotate, R to scale, and Y to activate the multi-tool. By now, you probably noticed that some numbers were changing in the inspector window as you were manipulating the cube. Here you can see all of the components of an object and its relevant variables. We will talk about them in the next section, but for now, let's take a look at the transform component of the cube as an example. As you can see, transform represents the position, rotation, and the scale of an object. We can manipulate all of its values from this window. Similarly, we can manipulate every field we see here. Let's move on to the game view. Many people confuse this window with the scene view. It is a common beginner mistake. The difference is that this view represents what the player will actually see when playing the game. In this view, you cannot click or edit any objects. To better understand it, go back to the scene view and select the camera. At the right bottom corner, you will see the camera preview window. Right now, you have only one camera in the scene, so it is identical to the game view. Now select the cube and move it in front of the camera. Switch back to the game view and you will see it there. Try to click on it and move it, and notice how nothing happens. Of course, you can modify the values from the inspector window and manipulate the object in that way. The bottom of the screen is occupied by the Project tab. This tab shows the Assets folder in your project. You can see this folder by navigating to the project folder you created at the beginning of this video. I put it to D, Projects, Unity 2019, Tutorial, Awesome Packed Game. Here you can see other folders that Unity has automatically created. Go to the Assets folder and you should see the Scenes folder, which is the same one as in your Project tab. Depending on your settings, you might see scenes.meta file in the Assets folder as well. Don't worry about it and definitely don't delete it. Unity keeps references to assets, files, and folders in these files. Alternatively, you can right-click on any folder or file in the Project tab and click Show in the Explorer to quickly open it up in the Explorer. This menu should be named as Reveal in Finder in the macOS. As an exercise, right-click anywhere in the Assets folder, go to the Create menu, and click on the folder. This will create a new folder. You can name it whatever you like. Then right-click on the new folder you just created, click on the Show in the Explorer, and you will see the new folder in the Explorer as well. If you delete the folder from the Explorer, it will be deleted from the project window, just as expected. The final window I would like to mention right now is the console window. Here, Unity prints out some very useful messages, such as errors and warnings. Or you can print out a message from a script as well. It will be a very useful window once we begin to code. I will go into the details in future videos. The thing I like the most about the Unity UI is that you can arrange it as you like. To do that, just click on the tab and move it around. Unity will snap it if it is in a specific position, or just leave it as it is otherwise. For example, having the scene view and the game view side by side can be very useful sometimes. You can close windows you don't currently need by right-clicking on the tab and choosing the Close tab option, or by clicking with the middle mouse button on the tab. Similarly, you can add a window by right-clicking on a tab and going to the Add Window menu. You can find more windows in the window menu at the top. I will rearrange the UI to the layout I find the most useful. A layout can be saved at the menu at the top right corner over here. In this video, you've learned how to create a new project, Unity's interface, and how to manipulate objects in the scene view. Of course, this is not all there is to learn about Unity's windows and their functionality. But these are the basic and the most relevant ones. Now we can proceed to create some stuff and to begin to work on our game. In the next section, you will learn about game objects, prefabs, and assets. In the first section, we took care of the installation of the necessary software for this course and got a quick look at Unity's interface. In this section, you will learn about game objects, prefabs, and assets. So let's begin with the game objects and components. Everything that you can see in the scene view or in the hierarchy is a game object. Game objects do not have to be visible in the game but still can have a function. You should see two game objects in the hierarchy, main camera and directional light. Neither of them will be visible, but as you can tell from the names, one of them will serve as a camera and the other as a light source. Click on any of them and you will see its properties, or rather components, in the inspector window. Each of these components provides certain functionality. For example, on the directional light object, you will see a light component. Similarly, on the main camera, you should see a camera component. You can add or remove components or edit them from the inspector window. Let's try it out on an example. First, create an empty game object using the Create menu in the Hierarchy window, or just right-click in the Hierarchy window and click on Create Empty. This is the most basic game object. You can change the name of an object by selecting it in the hierarchy and clicking on it once more, or by pressing the F2 button on your keyboard. As you can see, it has a transform component. As I mentioned in the previous video, transform holds the information about the position, rotation, and the scale of an object. Since each game object needs to know where it is in the 3D space, it has to have a transform component. Notice that you still can change the position, scale, and rotation of this object. But since it is not visible, we won't see any change besides the position in the scene view. So let's make it visible by adding Mesh Renderer and Mesh Filter components. Mesh is basically a 3D model, and the Mesh Filter component will store the reference to a 3D model. Renderer component will tell Unity to draw the model specified in the Mesh Filter component. Click Add Component button and you will see a drop-down menu with different categories. You can search for a component by directly writing its name in the search field or by navigating in the menu manually. Since we know what components we want, let's just search for them. First, Search for the Mesh Filter component and click on it to add. Then click on this circle next to the mesh field. It is a picking tool. It will automatically open a new window listing all available objects you can set to this field. You can choose from the current scene or the assets. Since we don't have any meshes in the scene, choose the Assets tab and select a cube mesh. We added the mesh, but still cannot see it in the scene view. It is because we don't have the mesh renderer component yet. Add it in the same way you just added the mesh filter. And there is your cube. If you don't see it in the scene view, then probably it means that you are not looking at it. Make sure that the cube is selected in the hierarchy. Move the mouse to the scene view and press F button on your keyboard. This way you can focus on an object. Note that you can do this the other way around as well. Select an object from the scene view, move the mouse to the hierarchy and press F. The selected object will be highlighted. This will become very useful when you will have more complex scenes. Now you definitely should be able to see it. The only problem is its color. This particular color indicates that there is something wrong with the shader of the object. In our case, the problem is that we haven't set any yet. We will talk about shaders and materials in later videos. For now, click on this arrow over here and it will expand the material list. Again, don't worry about the exact meaning of it. I will explain it in more details in the following videos. If the size is 0, make it 1 and element 0 should pop up. Set the material just like we did with the mesh. Choose the default diffuse material and the cube should turn to gray. And finally, we made our very first 3D cube in Unity. If you paid attention to the Create menu before, then you probably have noticed submenus like 3D object, 2D object, and so on. In those menus, you can find some more preset game objects. For example, if you choose 3D and click on the cube, then Unity will create a new cube, just like ours. The only difference is that it has one more component, Box Collider. Colliders define the physical boundaries of an object. We will go in more details in the final video of this section. The next very important thing I would like to talk about is the parenting of the objects. To better demonstrate what it means, select one of the cubes you just created, reset its position and rotation to 0. You can do it manually or by clicking on this cog icon and selecting the Reset option. It resets all of the component's variables to default values. Focus on a cube and create a sphere. Move the sphere next to the cube, then in the hierarchy window, drag the sphere on the cube. Notice how in the hierarchy window, the sphere has a slight offset. It means that it is a child of the cube. Now it will move, rotate, and scale relative to its parent. Just select the cube, move it around, and you will see that the sphere is following it. Also, notice how the transform values of the sphere do not change. The reason is, as I mentioned before, these values are relative to the parent of an object. There is one last useful tip I will mention in this video. See these two buttons at the top of the editor window? Right now, they should be set to local and pivot. If you hover the mouse over them, their tooltips will appear. Toggle tool handle position and toggle tool handle rotation. When the rotation is set to local, you will see the axis indicator of the object is in its local space, meaning you will see these indicators pointing in the object's respective axis, not global ones. Click on it to toggle, and you will see that it has changed to global, and the axis indicator points in the same direction as the global axis. Now select the parent cube object, toggle the pivot button, and you will see that the axis indicator moves in between the cube and the sphere. Right now, it is at the center of mass of the object and its children. All of these settings can be useful in different situations, so just keep them in mind. For now, I will leave them as pivot and global. Finally, to remove a component, click on the cog icon and click on the Remove Component option. And that is it for this video. So far you have learned how to create game objects, how to add, remove and manipulate components, and what parenting means in Unity's context. In the next video, we will take a look at how to save game objects we have created, or in other words, how to create prefabs and how to manipulate them. So see you then! In the last video, we talked about creating the game objects, adding, removing, and manipulating components. Now we need to save them somehow, so we don't have to recreate a game object each time we want to use it. And this is what I'm gonna talk about in this video. So let's begin. First of all, we will need a game object to save. I will create a cool agent guy as an example. Create a capsule and a cube. Reset their transforms, make the cube child of the capsule. Rescale and reposition the cube so it would represent the sunglasses. Later, we will make them black. Also, I'm gonna rename the capsule to Cool Agent Guy. To save this object, or in other words, to create a prefab from this object, just drag and drop it to the Assets folder. See how it turned blue? It means that this specific game object is linked to a prefab. Click on the Select button to select the prefab asset. To create a new game object using this prefab, just drag and drop the asset to the scene view or to the hierarchy window. You can create as many copies of the agent as you like. A quick note, you can change the size of the icons in the Project tab with this slider. I prefer to make them as small as possible. Select the prefab asset and take a look at the inspector window. If you are using Unity 2018.2 or an earlier version, you will see pretty much the same thing as you would if you select the game object in the scene. The reason for this is that Unity recently reworked its prefab system to support nested prefabs, or prefabs within prefabs. We will talk about it later in this video. Now take a look at the inspector window and you will see this preview of our agent. You can rotate and inspect it by holding any of the standard mouse buttons. Also, you can resize or completely close this window. Click on the Open Prefab button and you will see that it opens up in a different environment. This is the place where we will be editing our prefab. Let's say that we don't really like how the sunglasses are positioned. Select the cube from the hierarchy or from the scene view and move them around just like you would move them in a regular scene. Also, we probably want to change the name to sunglasses. Click on this Save button or press Ctrl S on the keyboard to save the changes. Or toggle the autosave option if you would like for the progress to be saved as you work on the prefab. Click on this arrow to go back to the regular scene view and you will see that all of the agents are changed. This is one of the main reasons you want to use prefabs a lot. Imagine that you have a lot of red cars in the game which were created from one single prefab. If, at some point, you decide that you want them to be blue, you don't have to change the color of each car. You only have to change the color of the prefab and you are done. Let's do this the other way around. Select an agent and change its scale. Notice how the scale label and the values become bold. It means that these values were modified and are different from the prefab value. Click on the Overrides menu in the top right corner of the inspector window. Here you will see all of the modified components, in our case it is only the transform, and two buttons, Revert All and Apply All. The Revert All button will revert all of the modified values to the prefab values. The Apply All button will change the values of the prefab with the modified ones. Click Apply All and pay attention to other agents in the scene. Their scale should be updated to the new value. Click on this arrow to open the prefab mode and see how the scale is updated in the prefab as well. Now let's assume that you modified more than one value but only want to apply one of them to the prefab. To do that, simply right-click on the value and click on Apply to Prefab option. Same goes for reverting a value. Right-click on the value and click Revert. If you don't want to search for all of the modified values, open the Overrides menu and check the component list. This list only contains components with modified values. Click on any of those components and you will see a window similar to the inspector, but only displaying that particular component on the right side and its prefab values on the left. You can modify the values or revert or apply the changes to the prefab just like you would inside a regular inspector window. One important thing that you should keep in mind is that the modified values won't be affected by the changes in the prefab. For example, select one of the agents in the scene, set its scale to 0.5 on all axes, then open the prefab and set the scale values to 1.5. Save the prefab and return to the scene. Check out the other agents and see how their scale values did change, but the one we modified remains at 0.5. So far you have learned how to create and modify a prefab. Get used to it since you will be using prefabs a lot. In the next video, we will continue to discuss the prefabs in more depth. See you then! In the previous video, you have learned how to create and manipulate prefabs. In this video, we will continue to discuss this topic in more depth. The first thing I will talk about in this video is the prefab variants. Let's assume that some of our agents will be small and some of them will be big. All the other properties will be the same across both small and big agents. One way of creating a variant prefab is simply dragging the game object from the hierarchy to the assets folder. If the game object you just dragged already has a prefab reference, then Unity will ask you if you would like to create a variant or an original prefab. If you choose to create the original, then the new prefab won't have any connections to the old one. So click on the variant prefab and notice the two little arrows on the new prefab icon indicating that it is a variant prefab. Now you can use it as a regular prefab. I will change its name to small agent guy. If you modify any value in the variant prefab, it won't affect the original one. However, if you modify the original prefab and the values in the variant prefab are not modified, then they will be affected by the change. For example, select a small guy in the hierarchy window, change the cast shadows and reflection probes option in the mesh renderer to off. Right-click to one of those to apply the change to the prefab. This time you should see three options. Apply as override in prefab small agent guy, apply to prefab cool agent guy, and revert. The revert option will revert the value to variant prefab's value, and the apply to prefab option will apply the change to the original prefab. So let's apply the new reflections probe changes to the original prefab by clicking on the apply to prefab option. Apply cast shadows changes to the variant prefab by clicking on the apply as override in the prefab option. Then select a cool agent guy and check out the options we just changed. Reflection probes should be changed to off and cast shadows should be set to on. Now change the reflection probes to blend probes and skybox and cast shadows to two-sided. Apply all of the changes to the prefab and check the small agent guy. The reflection probes should be the same as the cool agent guy because we didn't override them in the variant prefab. However, the cast shadow option should still be set to off because we did override it in the variant prefab. If you open the prefab of the small agent guy, you will see that all of the overridden values are highlighted and you can revert them to the values of original prefab or apply them to the original prefab. If all of it sounds too complicated, don't worry. Just play around with prefabs and variants for a while. Eventually, you will understand how intuitive the system actually is. Finally, let's take a look at the nested part of the nested prefab system. It means that you can put a prefab inside another prefab. Let's work on an example. Create a gun for our agent real quick. Now make it a prefab and drag it under a cool agent guy object in the scene. You will see a little plus icon next to the prefab icon. It means that this game object was added but not applied to the prefab. Check out the prefab of the cool agent guy and you will see that indeed this is the case. Go back to the scene, right-click on the gun, go to the Added Game Object menu and you will see a familiar submenu. Click on Apply to Prefab Cool Agent Guy. Check out the prefab once more and you will see that the gun is added to the agent. Notice how the gun icon is blue, just like any other prefab. You can click on the arrow and open the gun prefab, just like you would do in the regular scene view. All of the things we learned so far will apply to the nested prefabs as well. As a bonus, let's talk about materials and shaders. Shaders are basically programs that tell the video cards how to draw objects. They determine stuff like colors, transparency, the glossiness of an object, and many other things as well. They are way too complicated to talk about them in detail in this course. Let's take a look at the materials instead. In Unity, materials serve as an interface between the user and the shader and makes shaders easy to use. To better understand what I mean, create a material by right-clicking in the project window, select Create menu, and choose Material. To apply material to an object, select that object and change the first material in the materials list to the new material we just created. Or simply drag and drop the new material to the object. You won't see any difference because it is still a default material. Let's play with its parameters a little. Either scroll down to the bottom of the inspector with the game object selected and expand the material if it is not expanded already, or select the material from the Assets menu. It doesn't matter where you modify the material from. Whatever you do in the scene view will automatically apply to the asset and vice versa. At the top, you will see the name of the material and right beneath it the shader field. Using this menu, you can change the shader of this material. There are some shaders which are better suited for specific use cases, but for our purposes, the standard shader will do just fine. All of the remaining parameters are specific to the standard shader. The naming convention will be more or less the same, but you won't see every parameter on every shader. For now, we will change only the albedo color, which is the main color of a material. Just click on the color and choose black. And finally, we have our sunglasses. We can also choose a texture with the picking tool, or by dragging and dropping it in this slot, but right now, we don't have any, and we don't need it anyway. I'm gonna show you how it works in later videos. Now let's make the sunglasses transparent. They are made of glass after all. From the rendering mode, choose Fade, click on the color and decrease the alpha value a little. Check out the sunglasses, they are transparent now. Well, I think it's quite a lot to process. You have learned how to create and manipulate the prefabs, which is one of the most important parts of game development process using the Unity engine. You should be proud of yourself if you made it this far. Just play around with the prefabs and get used to them. You will be using them a lot. In the next video, we will see how to import an asset from the asset store, and we will walk around using the FPS controller. So see you in the next video. In the previous video, we talked about prefabs and how to manipulate them. In this video, you will learn how to download and import an asset from the asset store and how to use Unity's default FPS controller. By the end of this video, you will be able to walk around your scene. Before we begin, let's organize our project a little. Create prefabs and materials folder. Put Cool Agent Guy, Gun, and Small Agent Guy to the prefabs folder and test material to the materials folder. Also, let's work on a new scene. You can think of a scene in Unity as a level in a game. In fact, it is a very common practice to use scenes as levels. Save the current scene if you haven't already by pressing Ctrl S. From the File menu, click on the new scene or press Ctrl N on the keyboard. Don't worry, the agents are not gone. They are still in the old scene. Press Ctrl S again and choose a name for this scene and pick a folder to save it. I will name it as Test Scene. Let's put it in the Scenes folder, next to the sample scene. Now, go to the Scenes folder and see that there are two scenes, Sample Scene and our new scene. Double-click on the sample scene to open it, and you will see our agents. Also notice that you can see the name of the currently active scene at the top of the hierarchy window, or at the very top of the Unity. Switch back to the test scene. If you check the Assets menu, you can see the Import Package option. Since you don't have any packages installed yet, you won't see anything in this submenu except for the Custom Package menu. If you downloaded a package before, you can import it using this menu. To download a package from the Asset Store, go to the Asset Store window if it is open, or open it up from the Window menu, or by pressing Ctrl 9. So this is the Asset Store. Everyone can create any kind of asset and publish it and sell it on this store. You can find a lot of great assets and many of them are actually free. What we are gonna need is the standard asset package from Unity. So search for them and click when it pops up. Here you can see the contents and the description of the package and at the bottom you can see the reviews. Alternatively, you can browse the store from your regular browser, but you will have to switch to Unity whenever you want to download an asset. The download button should be over here. Click on it to download the asset. After the download, the button will turn to import. Click on it once more, and after the decompressing process, this window will pop up. Here you can see all of the contents of this package and can choose what assets you would like to import. Hold the Alt button and click on this arrow to collapse all of the subfolders. And by the way, this same trick will work in the hierarchy window as well. From Standard Assets, navigate to the Characters folder and select the first-person controller. For controller to work, we are going to need cross-platform input and utilities as well. Click on the Import button and wait for Unity to import the new assets. Don't mind these warning messages. For now, they are harmless. Click on the Clear button to get rid of them. Now we have a new folder in the project window, Standard Assets. Navigate to Characters, First-Person Character, Prefabs, and you will see two prefabs, FPS Controller and Rigid Body FPS Controller. We will use the former. Just drag and drop it in the Scene view or the Hierarchy window, and that is it. Of course, our character is gonna need a ground to walk on. Otherwise, it will just fall down forever. From the 3D Object menu, create a plane, reset its position, and move the controller above the plane. At the top, there are three buttons, Play, Pause, and Step. The Play button starts the game, and the Pause button pauses it. Step skips one frame. Pause and Step will be very useful, especially when you will be debugging your code. Go ahead, press Play, and finally you are playing your game. Walk around with W, A, S, D or arrow keys, jump with the space button, and hold Shift to run. There are a few things I would like for you to pay attention to. First, you cannot use or see the mouse cursor. The reason is that one of the scripts on the FPS controller locked it. Press Escape to unlock it. Second, you are no longer in the Scene view. This is the Game View tab. If you switch to the Scene view, you can look around the scene and see the current state of the game. The final thing is the log in the console window. It says there are 2 audio listeners in the scene. Click on the play button or press Ctrl P on the keyboard to stop the game. Check out the child of the FPS controller game object and you will see that there is another camera with an audio listener component on it. We won't cover this topic in this course, but you can have multiple cameras in the scene. In fact, it is a common practice to have a separate camera to render only the UI elements. But as the log suggests, you cannot have 2 audio listeners in the same scene. Since we are not gonna need another camera, just delete the main camera, clear the console, start the game, and you won't see that log again. And that is it for this video. Now you know how to use the default FPS controller to walk around and test your levels. In the next and the final video of this section, we will talk about 2 specific and most used components, colliders and rigid bodies. See you next time! Now that you know how to use a basic controller, it is time to build some levels. To do that, you are going to need to use a solid geometry, so that the character won't just pass through objects. And in this video, we will take a look at the components which help us to define such geometry, colliders and rigid bodies. Let's create a new cube, reset its position, and move it above the plane. Move the controller so it sees the cube. Click play or press Ctrl P to enter the play mode. Move towards the cube and notice that you cannot pass through it. Press the escape button to reveal the mouse and remove the box collider component from the cube. And now you will be able to move through it. Exit the play mode by clicking on the play button or pressing Ctrl P on the keyboard, and pay attention to the cube. The collider is back. This is a very important thing to keep in mind. Unity reverts all the changes that are made to a game object during the playtime. This is only true for the game objects that are in the hierarchy. Changes made to any assets in the Assets folder will be saved no matter what. Okay, so let's take a closer look at the box collider itself. First, notice the green lines when you select the cube. These are the boundaries of the collider. They don't have to correspond exactly to the 3D object itself. In fact, in most of the cases, they don't. The center of a collider is the offset from the pivot of the game object it is attached to. Change the x value to 2 and see how the boundaries have moved 2 units on the x-axis of the object. Enter the play mode and notice that you can pass through the cube itself, but you cannot pass through the collider. I will reset the center back to 0. Size of a collider is relative to the object it is attached to. Change the size to 3 on each axis, enter play mode, and now you cannot touch the cube because the collider is 3 times bigger than the 3D model itself. IsTrigger variable turns the collider into a trigger area, which means that it won't interact with the physical object around it, but it will let you know if anything enters or exits the area. Enable the IsTrigger variable and you will see that you can pass through the cube like it's not there. We will use this property in our scripts to detect if the player entered the certain area or not. This material is not the same as we used in the previous video. This one is called physics material and it determines how the collider responds to collisions. But we won't be needing it in this course. Click on this button to edit the collider boundaries from the scene view using these dots. Disable the IsTrigger variable and let's move on to rigid bodies. Add the component to the cube and enter the play mode. See how it falls? And you can actually push it around. Awesome! As you probably already guessed, the rigid body component turns the cube into a physical object. Of course, it still needs a collider to interact with other objects. If you remove the box collider and play the game, you will see that the cube falls through the plane. Add it back and let's take a look at the component. Mass is pretty much self-explanatory. It is the mass of this object. Drag is the friction. It will affect how much the cube slides after it is pushed or how hard it is to push it. Angular drag is the same thing but only for rotations. We won't be using them in this course. Use gravity is pretty much what it says it is. Remove the tick if you don't want this object to be affected by gravity. Let's try it out. See how it floats as if it is in a vacuum? Now try the same thing, but with drag and angular drag, both set to 1. Push the cube and observe that it stops pretty quickly. If you turn isKinematic variable on, the cube won't respond to the physical interactions from the outside world, but we will still be able to use the rigid body properties and detect collisions from scripts. Turn it on and try to push the cube around. Interpolate and collision detection will affect the calculations of the movement and collision detection of the rigid body. Changing them will make the calculation of the movement and collision detection more precise, but it will decrease the performance of the game. The default settings work good enough for the most cases. The info part provides information about the current state of the object, but we won't using it much. There might be some cases when you would like to constrain movement or rotation on a certain axis. And that is when you will use the constraints variables. To see how they work, disable gravity, enable freeze position on x and y axis, and freeze rotation on x and z axis. Enter the play mode, push the cube, and see how its position is changing only on the global z axis and rotation only on the global y axis. And that is pretty much for this section. In this section, you have learned basics like creating and manipulating objects and prefabs. Finally, we talked about the most used components and implemented the first-person controller. In the next section, you will learn the basics of level design and how to create level prototypes in Unity. And finally, we will begin to work on the level of our game. As an assignment, try to create a playground for the first-person controller to walk around. Experiment with prefabs, colliders, and rigid bodies. Try to use a sphere collider to create a football game. See you in the next section. If you watched the previous sections, then by now you should know how to work with game objects, prefabs, and components and how to use the first-person controller. Now it is time to dive into the world of 3D level design. Well, perhaps not dive, but dip our toes a little. It is a separate discipline after all. In this video, you will learn some basic principles and techniques of level design. We will begin by discussing the white boxing technique. First, let me define the term. White boxing is a technique of creating the general geometry of a 3D level using basic shapes like white boxes. Hence the name. This technique is also referred to as gray boxing. Remember that assignment from the last section? Yeah, it was basically a white boxing exercise. Note that white boxing and gray boxing has a different meaning in the software development context. Okay, cool. But why do we need it, I hear you ask? Great question. To answer that, let's imagine a hypothetical scenario. Imagine that you are a level designer of an online FPS game. You have this awesome idea for a level. You quickly draw the layout on a paper, roughly describe it to the art team, and they begin to work on it. A week later, they are sending you the level with all of the props and models in place. Pretty. But wait, this doesn't seem to be right. That building should have been much taller, and that tree should have been much smaller. In fact, most of the scale is off, and the player cannot fit through that shaft at all. Well, okay, no big deal. These assets could be slightly rescaled, and with a few days of hard work, the level should be up and running. You give the feedback to the art team. They are not super happy about it, but tell you that it will be ready in about 4 days. You get the new level after 4 days, and it is still not what you think it would be, but at least it is playable for the most part. Again, you give the feedback to the art team, they are slightly annoyed, and begin the playtesting. A few days later, you got the report from the testers. Turns out that this balcony is a game breaker. If a player gets there with a sniper rifle, he or she will be practically invincible. The player cannot jump high enough in a corridor to avoid a trap. 1/3 of the map remains unused, because there is no point going there at all, and a third of the assets are thrown away. Do you want to do another iteration and spend another couple of weeks? What if the level is still not good enough? I guess you see where I'm going with this. Instead, you could create a level using only basic shapes and get the proportions just right in a single day. Test it and fix the issues on the fly by simply moving boxes around. And finally, only when you are satisfied with the level, pass it to the art team so they can start working on the art, knowing that there won't be any major changes and their work won't be thrown away. Of course, there still will be some changes, but at least now you know that the foundation is solid and the level is actually fun to play. As you can see from this example, the advantages of white boxing are pretty clear. You can prototype, test and iterate the levels pretty fast. It significantly reduces the number of revisions that need to be done by 3D artists, and much less of their work will be thrown away. Of course, the boxes do not have to be white. There is no authority deciding on what is a white boxing and what not. The point is to quickly create and test a level without getting lost in the details. Use spheres, capsules and some colors to better define areas. Just don't go into details so you can quickly change any part of the level for the next iteration. You don't actually need Unity or any tools to do white boxing either. You can use any 3D development software. Just make sure you can easily export a 3D model to Unity. But since it is a Unity course, we will cover a very useful tool called ProBuilder. It is a powerful tool created specifically for this purpose. Depending on the art style of your game, ProBuilder might be all you need to create final levels for your game. Check out Superhot. It was developed using ProBuilder. So I hope I convinced you to use white boxing as a level design technique. In the next video, we will talk about the basics of 3D level design principles. See you then! In the previous video, we talked about prototyping a level using white boxes. In this video, we will dive into some more theory and discuss what a good level design is and how to guide a player through your levels. While it is impossible to come up with a mathematical formula for a good level design, there are some good practices and principles to keep in mind when designing a level. A good level should be, first and foremost, fun to navigate. The player should not feel lost. Or if she is, the means to find the correct path should always be there. It is not fun to wander around the same corridors not knowing where to go. This can be accomplished by placing landmarks, distinct pathways, or using lights and colors as signposts. We will talk about this in more details in later videos. Similarly, the player always should know what to do. The objective should be clear. Climb that hill over there, unlock this door, get those crystals, etc. To keep things interesting, we can make the solution less obvious. In other words, the player has to know that she must unlock that door, but she must figure out how to do it by herself. Keep in mind that you have to be absolutely sure that the player knows how to use the tools required to solve the problem. If the player needs to use a double jump to reach the high ledge, make sure that she knows there is a double jump and how to use it. The level should make a good use of players' abilities. Can the player double jump? Make your level more vertical with wide gaps. Can the player turn invisible? Create a room where she can sneak past the guards. Even better, encourage the player to combine her abilities. Reward her for the exploration and performing advanced tricks and combining the abilities. Present the opportunities to use the abilities in different ways. Think about Portal. The main, and pretty much only mechanic, is shown within the first 10 minutes of the game, and it is what you do throughout the rest of the game. However, almost in each level the developer teaches you a new way to use the portals, keeping the gameplay interesting. Imagine the following scene. Player enters a large hall and sees the bad guy escaping through the large door at the other end of the hall and locking it behind him. The player immediately notices a window above the door. It is very easy to notice because the frame is painted in a bright red color. The problem is the window is high above the ground, clearly out of the reach of the player. So the objective is very clear. The player needs to get to that window. How? The player remembers that she can move some objects around. Or perhaps she can find a key to unlock the door. Also, there is a balcony on the right side of the window. Finding a way there might be a solution as well. On the left side of the window, there is a shelf with an ammo crate on top of it. It doesn't seem like the player can make the jump from the balcony. What about sprinting? Perhaps sprinting before jumping will help? Or pushing a box to the edge of the balcony, then sprinting and then jumping. Yes, the player can make it. So the player has to find a solution to a clearly stated problem using the tools introduced in previous levels of the game. By being creative and combining what she learned so far, she can also get a bonus. If there is a fall damage, then this tricky jump will be a great example of the risk-reward mechanics. Implementing such risk-reward mechanics can provide seasoned players with an extra challenge. The player can decide for herself if she wants to risk losing some portion of health for some extra ammo, thus providing an extra challenge. If the player decides that she can't make the jump, it's okay as well. She can pass it and just focus on the main path. And this is it for now. In this video, we talked about how the levels should be from a mechanical point of view. Think about your favorite games and how the levels are designed with these principles in mind. Think about the times you got lost in the game and think about why. Bad examples are also great to analyze and learn what doesn't work. In the next video, we will discuss how levels should look and feel. See you next time! In the previous video, we talked about the level design from the mechanical point of view. In other words, we talked about how the level should function. Now, we will discuss how a level should look and feel. So let's begin. While designing a game in general, I'm trying to ask myself a question. How do I want the player to feel during the gameplay? After all, a serial killer in a horror game won't be so intimidating if the player has an assault rifle with unlimited ammo and the game takes place in a large open area where you can clearly see the killer slowly walking towards you. So the first thing to consider is the emotion of the level. Do you want the player to feel empowered? Give the player character a powerful weapon and a high ground where she can clearly see all of the enemies. Want to make her feel vulnerable? Make sure that she thinks that threat is always nearby, that the monster hunting her might be just around the corner or watching her from that dark spot. Want to make the player feel relieved? Create open and well-lit area after a fast-paced chase in a dark corridors or caves, or a safe spot where the player knows for sure that nothing bad is going to happen. As you can see from these examples, levels can be and should be more than a set of rooms and corridors that connect certain challenges. Aside from conveying or amplifying emotions, levels can be used to tell a story. Imagine entering a room on the second floor of a building, seeing bullet holes on the wall, a broken window, some blood on the wall, and empty bullet shells at the entrance. Immediately, you imagine that somebody with a gun walked through the door and tried to kill someone who was in the room. Clearly, the victim was shot, but it looks like he or she made a last attempt at escape by jumping off the window. Or perhaps the window was broken by the gunfire and wounded victim surrendered. Such details make the world more believable and can deliver stories without explicit dialogue or cutscenes. Unfortunately, we won't be able to apply everything we just discussed in our game. We don't have enough time and it is not the focus of this course. But keeping these principles in mind will help you to create better levels in the future. To better understand how space affects us, I suggest reading some architecture books. Those guys were creating experiences in a 3D space for thousands of years, and by now, they do know what they are talking about. Specifically, I recommend reading a book called An Architectural Approach to Level Design by Christopher Totten. And that is it for this video. Now that we know what to pay attention to, we can go ahead and begin to build a level for our game. We will begin with the whiteboxing, and to do that, we are gonna use ProBuilder. See you in the next video where I'm gonna show you how to use it. So far in this section, we talked about the theoretical part of designing a level. Now let's dive into the practice. In this video, I will teach you how to use the ProBuilder tool for whiteboxing. Before we begin to use ProBuilder, let's talk about the ProGrids. Basically, it is a more advanced version of the snapping tool. Aside from moving objects discretely, like when you're holding the Control key, it also snaps objects to the grid. I will show you what I mean after we install the tool. Note that it is not mandatory, but it will make your life much easier when you work with the ProBuilder. To install the ProGrids, go to the Window menu and open up the Package Manager. Click on In Project menu and select All Packages. At the time of this recording, the ProGrid tool was in the preview. If it is still the case, then click on Advanced and Show Preview Packages option. Now, you should be able to see the ProGrids package. Select it and click Install to install the tool. After the package is installed, close the window, and you will probably notice that nothing has changed. To activate the ProGrids, click on the new Tools menu, and from the ProGrids, click on the ProGrids window, and you will see a new menu in the Scene view. This is the ProGrids menu. I won't cover it in details since it is very well documented. Just move the cursor on a button and the description will pop up. What we are mainly interested in is the increment number over here. It is the snap increment. If you set it to 0.5, the game objects will move by 0.5 units each time you drag them, just like they would when you're holding the Control key. Let's set it to 0.1 and move on to the ProBuilder tool. Install the ProBuilder tool from the Package Manager, just like you installed the ProGrids. To bring up the ProBuilder window, go to Tools menu, ProBuilder, and click on the ProBuilder window. Dock this window wherever you like, just make sure it is easy to access. We will be using it a lot. If you worked with a 3D modeling tool like Blender, Maya, or 3ds Max, many of these menus will look quite familiar. In fact, you can think of it as a simple modeling tool, like Paint but for 3D. Again, all of these menus and buttons are pretty well documented, so don't worry if you miss something or forget what a button does. Just hover over it and you will see the tooltip. From this menu, you can choose between text and icon modes. The icon mode is more useful if you know your way around. So until then, we will use the text mode. Before we begin to create anything, you might want to disable the automatic light baking. Basically what it does is it calculates the light and draws the shadows to textures. It saves a lot of performance in the runtime, but the process itself is quite heavy, and we don't need it at the moment. So navigate to Window, Rendering, Lighting Settings, go to the bottom of the window and disable the Auto-Generate option. You may want to clear baked data as well. Close the window, you won't be needing it. Let's begin from the top, the New Shape tool. If you just click on it, it will create a default shape, a cube. Even though it has a nice texture, you didn't install the ProBuilder for the cube. Unity already has it. So delete the cube and click on the plus icon and the shape tool will appear. From the shape selector, we can choose one of many predefined simple shapes or define our own by writing down vertex coordinates. For now, let's stick with the cube. There is only one option under the shape settings category, the size. Let's set it to 5, 3, and 2. Now, if you close the window, the cube will disappear. You can think of it as a preview. Open the Shape tool again and click Build. Now we can close the window and we will have our cube. Now pay attention to the buttons at the top of the scene view. There are 4 new buttons, or rather toggles: Object Selection, Vertex Selection, Edge Selection, and Face Selection. Object selection is the default mode we've been using so far. Enable it to manipulate the whole object. Switch to the vertex mode. Now we can manipulate individual vertices. Of course, rotating and scaling them will not change anything, since a vertex represents only a position. Switch to the edge selection to manipulate edges. You can use translation, rotation, and scaling tools to manipulate it as well. The face selection is pretty much the same thing, but used to manipulate the faces of an object. Now let's take a look at the stair shape in the Shape tool. Select the stair option from the Shape selector. Now you can see some new options in the Shape settings. These options are different for every object, and most of them are pretty self-explanatory. If you are not sure what an option does, read the tooltip or just change it and immediately you will see the results. Check out other shapes and play around with the options. And that will be it for this video. In the next video, we will continue with the Pro Builder tool. So see you then. In the last video, we installed the Pro Builder tool and begin to learn how to use it. In this video, we will continue to learn Pro Builder. The next function we will take a look at is the new poly shape. This is a good opportunity to demonstrate why ProGrids is so important. Set the snap value to 1, then click on the new poly shape button to begin create a new shape. Click anywhere to create a vertex for the shape and notice how the vertices are automatically snapping to the grid. Without the ProGrids, it is very hard to create a geometrical shape. After creating the base for our shapes, press the Enter or the Space button on the keyboard and set the height of the object by moving the mouse up or down. Click one more time to create the new object. Check out the inspector and you will see the polyshape component. Here you can flip the normals of the object, change its height by changing the extrusion or edit by clicking on the Edit Polyshape button. The next cool tool we will take a look at is the Material Editor. With this tool, you can quickly paint objects or individual faces using materials. Open it up and you will see a palette. Drag and drop the materials to the slots or use the picking tool to set the materials. Select an object or a face and click the button next to the material to apply it, or use the indicated shortcut. To create your own palette, click on the drop-down menu and click on the New Material Palette. It will create a new Material Palette asset to the Assets folder. You can switch between palettes either by dragging and dropping them in the Material Palette field, or by using the Picker tool or the drop-down menu. Increase the size of the array of the new Material Palette if you would like to use more than 10 materials. Or just use the Add button in the Material Editor. It will do the same thing. Click on this red button to remove material from the palette. Note, however, that you won't get a shortcut for extra materials, and you will have to open the Material Editor window each time you want to apply material to an object or a surface. Similarly, you can paint individual vertices using the Vertex Color menu. Just select a vertex, click the Apply button and immediately you will see the effect. If you don't want this color interpolation, select the face instead of a vertex and click Apply. The Subdivide Object menu will divide each face of an object to 4 smaller ones. Create a new cube, select it, subdivide, and you will see that each side consists of 4 faces. You can subdivide an object as much as you like. You can do this for an individual face by selecting one and click on the Subdivide Faces button. Now let me show you a cool trick that you will be using a lot during the prototyping. Extruding faces. First, select a face, try to pull it, and see that it affects its neighbors as well. Now click on the Extrude Faces option and see that it went up without affecting the neighbors. The same thing can be achieved by holding the Shift key and moving the face. The extruding with the Shift button can be used with the Scaling tool as well. Select a face, switch to the Scaling tool, hold the Shift key, and scale down the face. Now switch back to the Moving tool, hold down the Shift key again, and move the face inside the cube to create some kind of a corridor. To delete a face, edge, or a vertex, simply select it and press the Backspace key. Delete the face we just created and the one on the other side. We have a tunnel. Cool. But as you can see, we need to cover this part so the player won't see through the geometry. To do that, switch to the Edge mode, select two opposing edges, and click on the Bridge Edges button. If you have more than two edges, you can use the Fill Hole button to create a single face between multiple edges. Select an edge and click on the Select Hole button to automatically select the edges surrounding the hole. So now that you have learned the basics of the Pro Builder, it is time to build a level for our game. I have skipped a few menus because they were either self-explanatory or required another video to explain. And we are not gonna need them anyway. The next video will be more like a speed level design rather than a tutorial. I will make a few remarks as I build the level, and you will see the Pro Builder in action. See you then! So far, you have learned everything you need to know to prototype a level, and that is what we will do in this video. Without further ado, let's get started. First, I created the general shape of our level using the new poly shape. The height of the level is gonna be 10 meters. I have noticed that the unlit areas are completely black. Enabling auto-generation of light baking from Light Settings tab solved the issue. The directional light was too bright, so I reduced the intensity of the directional light. To carve out the space to walk in, I scaled the top face down while holding the Shift button. I set the thickness of the walls by moving the edges around. Then, I selected the resulting face and moved it down while holding the Shift key. To see whether or not the scale was correct, I dropped the FPS controller to the scene and played the level. We don't need the second camera, so I deleted the old one. This area is gonna be the bedroom where the player will begin the game. To separate it, I created a wall. To create the door, I subdivided the surface twice, selected some of the new faces, moved them holding Shift key, and deleted them to create the door. On the other side of the wall, I did the same procedure except for the moving part. Then, I created the stairs to the second floor and the second floor itself. I've added a couple of walls. This part will be a kind of a secret area. While it is not hidden, it will be easy to miss for a player if she is not paying attention to her surroundings. Now I'm making a roof for the bedroom. This will be the ladder, our final destination. Let's make a roof for the corridor as well. The player won't see this room at the top, so creating only the walls and the ceiling will be enough. Let's see how the level looks from the player's perspective. Seems like the stair got stuck into the wall. It is easy enough to fix. This is a good point to give a break. In the next video, we will finalize the prototype. See you then! In the previous video, we started building the prototype for our level. Now it is time to finish it. Let's continue by making some furniture and the important elements of the game. In the bedroom, there will be a bed and a work desk. Also, in the very beginning, the door of the room will be locked and the player will require a key card to unlock it. This will be the door. And I will make a key card out of a box real quick. The final important element in the room will be the TV. Also, we will have a console in the secret area of our level. The story bit over here will be a nice reward for the observant players. Finally, we will need a console to activate the ladder. I will make one using the new polyshape tool. I want it to be a glass door. Not much privacy, but it will look cool. So I have created a glass material and dragged and dropped it on the door. This wall over here will actually be a glass. Now let's paint the screens so we know what they are. Let's paint the ladder so that it stands out and the player can easily spot it. I'm gonna paint the furniture as well, so that the artist knows what these are. It looks like I forgot to remove the collider from the door. We will open it up with the script later on, but for now just remove the collider. It seems that TVs are a little too high, and you can see how a player can easily miss the secret area. And that is pretty much it. Now we can save our prototype and pass it to the art team. The best part is that we don't have to wait for the 3D models to start writing the code. We can work with this prototype and add the models as they arrive. In the next section, we will implement the assets finalizing overall design of the level. See you next time! In the previous section, you have learned how to prototype and test a level using ProBuilder. While it is possible to create a whole level using only the ProBuilder tool for 3D models, we will take a look at other sources for visual and audio assets. The first, and one of the best sources of assets for Unity, is of course the Unity Asset Store. We did make use of it in the second section. Now it is time to dive deeper. Open your browser and go to assetstore.unity.com. Alternatively, you can open up the Asset Store tab in the Unity editor itself, as we did in the second section. But I find that it loads faster in the regular browser. To download an asset, you will have to sign in to your Unity account, so let's do it now. Click on the Account button and you will see two options: Create a Unity account and Sign in. If you have an account, click on Sign in. Click Create a Unity account otherwise. Creating an account is a simple task, so I won't go into the details. Sign in and let's continue with the store. If you know the name of the asset you would like to get, or would like to search for a specific asset, you can use the search bar. Again, we used it in the second section. At the top of the page, you will see general categories for assets: 3D, 2D, add-ons, audio, templates, tools, and visual effects. Notice that when you hover over them, the subcategories will pop up. You can see all of your purchased and downloaded assets from My Assets over here. Favorites, notifications, and card buttons are pretty much self-explanatory. The Applications button reveals some other Unity services which we are not interested in at the moment. We know that we want to create a science fiction environment, so we can choose that category either from the drop-down menu next to the search bar or from the 3D category at the top of the website. Now we can browse through all of the science fiction themed 3D environments on the asset store. If you have a budget in mind, you can set the asset price from this drop-down menu. In our case, the budget is 0. Click Apply, and now you will see only the free science fiction themed 3D environment assets. Note that all of the assets in the Unity Asset Store are free to use both in the private and commercial projects, as long as the project is created using the Unity 3D engine. You can add an asset to your favorites by clicking on the heart at the top right corner. Click on the Quick Look button to check out an asset. To read the full description and the comments, click on the View Full Details button, and the asset page will open up. The description of the asset is on the right side of the page. Other details, like release date and supported Unity versions, are on the left side, below the screenshots. Scroll down to see the reviews for this particular asset. Notice that you cannot directly download the asset from the web browser. Instead of the Download button, there is Open in Unity button. Click on it to open this page in the Asset Store tab of the editor. Now you should be able to see the Download button. Click on it to download the asset, and after the download is completed, it will change to Import. Click on it once more to bring up the familiar Import tab. This time we are going to need all of the assets in the package. So just click on the Import button to import the whole package. Similarly, you can search for sounds, scripts, 2D assets, or even the whole projects on the Asset Store. But what if we didn't find what we need here? Well, contradictory to the popular belief, there are a lot of good people on the internet, and some of them create assets for free. I will tell you about the websites I use the most. First, there is Kenny. Visit his website, kenny.nl, and you will find a lot of nice 2D and 3D assets. If you feel like supporting him, you can purchase these assets from the store, but otherwise they are free to use. For free animations and humanoid models, check out mixamo.com. They have a huge library with motion captured animations and models. If you don't like their models, they have a tool called Fuse. It is a part of the Adobe Create Cloud, so you'll have to pay for the subscription. After that, you can import and rig your humanoid models quite easily. For the sounds, I suggest checking out the website freesfx.co.uk. The only thing they are asking for is accreditation. As long as you specify that you used the music or the sounds downloaded from this website in the credits, you are free to use it in any product you like. For the fonts, check out fontlibrary.org. The fonts over here are open source and free to use in any kind of projects. For the 3D models, check out turbosquid.com. They have both paid and free models on their site. Finally, I would like to mention opengameart.org. Here you can find all kinds of assets. Most of the assets published here are free to use, but still, pay attention to the licenses section on the left side. I'm sure there are a lot of more of the websites that you can visit to find free assets. The keyword you want to use while searching for them is royalty free. And that is it for this video. In the next video, I will show you how to import the assets that you have downloaded. See you next time! In the previous video, we talked about finding game assets online. Now let's see how we can import them to our project. Let's begin with the 3D models. I will download one from TurboSquid, but you can get one from wherever you like. If you would like to get one from TurboSquid, go to the website, click Login/Join, create an account if you don't already have one, or click on Login if you do. It might ask you for the verification number, which will be sent to your email. After the verification, you will return back to the main page. Click on 3D models, and from categories, choose Free Models. Choose one that you like the most. I will download this one. Click on the shopping cart. On the next screen, select the models you would like to download and click Download. Extract the folder somewhere easily accessible or directly to the project folder. If you have extracted it somewhere else, just drag and drop the folder to the Project tab. Most of the time, Unity takes care of the importing process and you don't need to change anything. However, sometimes it doesn't work as expected or you might need a different settings. So find the model in the Assets folder. Its icon is similar to the prefab, but has this little white symbol next to it. It indicates that it is a 3D model, not a prefab. Click on it and you will see the model in the preview window of the Inspector tab. At the top, there are 4 sections: Model, Rig, Animation, and Materials. Let's take a look at the model first. The first property is the scale factor. If the scale of the imported model is not correct, you can fix it using this property. Unity's physics system expects one unit in the game world to be 1 meter in the imported file. To see the effect, drag and drop the model into the scene, focus on it, change the scale factor to 2, and click Apply button at the bottom of the inspector. The model gets 2 times bigger. I'm gonna scale it back to 1. If you enable Convert Units option, then Unity should take care of the proper unit conversion between the 3D modeling software and the editor. If you turn it off, then most likely the scale of the model will change as well. If the model has blend shapes and you want to use them, turn on the Import Blend Shapes option. Otherwise, you can turn it off. Import Visibility option defines whether or not Unity should import FBX settings that define the visibility of mesh renderer components. If you want to use cameras defined in the model, leave this option on. Otherwise, you can turn it off. Same goes for the Import Lights option. Normally, the FBX importer strips any empty root nodes from the model as an optimization strategy. However, if you have multiple FBX files with portions of the same hierarchy, you can use this option to preserve the original hierarchy. Mesh Compression option sets the level of compression ratio to reduce the size of the mesh. Unity suggests to turn it up as high as possible without the mesh looking too different from the uncompressed version. This is useful for optimizing the game size. You should always disable the Read/Write option if you don't want to read or change the mesh data from the script. If you keep it on, basically there will be 2 copies of the mesh in the memory. Optimize Mesh option allows Unity to reorganize the mesh data for better performance. Always leave it on unless this specific option causes problems. Generate colliders is pretty much self-explanatory. Unity can generate mesh colliders for each mesh automatically. However, mesh colliders can impact the performance, so use primitive colliders like Box Collider and Capsule Collider whenever possible. Unity automatically converts polygons that have 4 vertices to triangles. Enable this option if you want to keep the quads for tessellation shader or something else. Well, the vertices option will combine multiple vertices that are in the same position to 1. Unity handles the index formatting automatically. Unless you are using GPU-based rendering pipelines, leave it on auto. If you don't want to use real-time lighting for this model, you can disable the normals by setting normals option to none. Otherwise, import the normals from the FBX file or let Unity calculate them based on normals mode, smoothness source, and smoothing angle. If you choose to calculate or import normals, you will see the tangents option. You can either set it to calculate or to none. I don't recommend using the legacy options. Use the Swap UVs option if your diffuse texture uses UVs from the light map. Generate Light Map UVs option creates a second UV channel for light mapping. This specific model does not have a rig or animation, so we will skip them for now. In the Materials section, You can choose whether or not you want to import the materials from the model. If your project is using linear gamma space, disable the sRGB albedo colors option. Our object don't use the linear gamma space, so let's leave it on. You can import the materials from an external directory using the legacy option in the location. But since it is legacy, I'm not gonna cover it. If you want to change the materials from the Unity editor, you can extract them into the project using this button. Just click on it and select the folder you would like to extract the materials, and you can edit them like any other material. Finally, you can remap the default materials using these options. But I won't go into details for this one. That is it for this video. In the next video, we will check out the importing options for other kinds of assets. See you then! In the last video, we learned the importing options for the 3D models and their materials. We will skip the animation and rig importing. It doesn't make much sense to import them if we are not going to use them. So let's continue with 2D images. I will make use of the background elements redux package I downloaded from the kenny.nl. As always, you can download this package from the website or use any other 2D image. From the package, I dragged and dropped backgrounds folder to the projects tab, just like we did with the model. Select an image from the backgrounds. The first option is the texture type. The default type is just a regular texture used on a model. Normal is the texture that holds the model's normal's information. Sprites are usually used for the visuals of 2D games. If you would like to set this image as a cursor, you should set its type to the cursor. A cookie is a texture that is used with a light source. Think of a bat signal and you'll get the idea. I have mentioned the light map textures before. Basically, these are the textures that contain light information, like shadows. If you are going to use only one color channel of your texture, you can set it to the single channel. Select the default and let's proceed with other options. The second option is used to set the texture as a cube map. Cube maps are mainly used for skyboxes and reflections probes. We won't use them, so just leave it at 2D. Unless this is an HDR texture, set the sRGB option to on. You can choose to use the alpha value of the texture or generate it from the grayscale using this option. Set it to none if texture does not have an alpha value. Turn on the alpha channel is transparency option if this is the case. Wrap mode describes how the texture behaves when tiled. Repeat repeats the texture. Clamp stretches the texture's edges. Mirror mirrors the texture at every integer boundary to create a repeating pattern. Mirror once mirrors the texture once, then clamps it to the edge pixels. You can choose per axis to individually control how Unity wraps the U-axis and the V-axis. Filter mode is the way that the texture is filtered when it gets stretched by 3D transformations. No filter mode is the one you want to choose if you are making a pixel art game. Otherwise, the visuals will appear blurry. An ISO level increases texture's quality when viewing the texture at the steep angle. Max size is the maximum important dimensions of the texture. In other words, Unity will scale down a texture if it exceeds this size. Try to set it equal or higher than the texture resolution to get the best results. Unity can compress the texture to save on memory. Specify the quality of compression using this option. Using crunch compression will help to save the disk space. However, this compression method is not lossless, meaning that the texture may lose some details in the process. There are many other options for the specific types of textures, but these are the most important ones. So let's move on to the audio assets. I have downloaded this MP3 file from freesfx.co.uk. You can use any file as long as Unity supports the format. To be safe, use either MP3 or OGG. As usual, drag and drop the file into the project. Select it and you can see its waveform in the inspector, and you can play the track using the play button. There are not many settings here and most of them are pretty self-explanatory, so I will explain only a few. Load in the background means that the audio file will be loaded on a separate thread. This can cause a delay. Use this option with the preload audio data option and load audio data function to avoid the delay. From the load type, you can choose how you want to decompress the audio. Decompress on load will decompress the file as soon as it loads. Large files using this option will use a lot of memory. Compress in memory keeps the file compressed while it is not being played. Streaming will decompress the file on the fly. And these are the three main file types you will be using most of the time. Now that we know how to deal with the assets, in the next video, we will replace our placeholder level with the sci-fi environments from the asset store. See you next time! So far in this section, we've learned where to get the assets from and how to import them in Unity. Now, it is time to use those assets in our project. As I mentioned before, I'm gonna use the sci-fi pack from Unity Asset Store. We downloaded it and imported it in the first video of this section. First, I'm gonna rearrange the scene. It is not super important, but it will make a navigation in the hierarchy easier. Basically, our level has 4 parts: the bedroom, the corridor, the second floor, and the exit. So I will reorganize accordingly. I will disable the ceiling of the bedroom so that it is easy to see what is inside. Also, for the sake of being organized, I'm gonna separate the prototype part with the final part of the level. For the walls, I will use these blue prefabs. Here I'm gonna cheat a little and change some of the scales to better suit the assets. For the ground, I'm gonna use this prefab. There is a bed prefab and the L-shaped drawer prefab in the package. I'm gonna use them. They are slightly big, so I'm gonna scale them down a little. Let's put a door over here. Now let's move on to the corridor. I'm gonna use this prefab as a kind of transition between two sections of the level. Such portals usually serve a pretty important role in separating areas. It makes it easier to keep in mind what is where in the game world. I'm gonna move the room a little so we can fit in this small corridor piece. Let's check out how the bedroom looks from the player's perspective. Some of the walls in the main corridor will be different, so it is not very boring. For the rest of the corridor, I'm gonna use different walls that I used for the bedroom. The reason is, again, to differentiate between the different areas of the level. The walls in the secret area will be different for the same reason. There is a very nice console prefab in the package. I'm gonna use it. That will be it for this video. In the next one, we will continue to implement the models. See you! In the last video, we began to implement 3D assets to our level. So let's continue. Now I'm gonna build the floor. I will use this prefab to build a kind of path for the player. It will guide the player through the level in a subtle way. Even if you didn't pay attention to it, intuitively, you will want to follow it. Looks like I accidentally deleted a wall over here. Now let's disable the door and see how it looks. You can see now what I meant by the path. There are a couple of stair models in this package. I'm gonna use one of them. Also, I will add a door before the stairs. Once again, both the door and the stairs will separate two parts of the level. And let's move on to the second floor. That will be it for this video. In the next one, we will continue to implement the models. See you! In the last video, we begin to implement 3D assets to our level. So let's continue. This is the glass prefab I will use. As usual, the walls will be of a different color. There is this nice table with the computers on top. I will use it as the console. I have realized that it will be better if there is some space on the right side of the level. So I moved the bedroom to the left. Now I will build the ceiling using these tiles. It seems like the floor tiles are slightly off. This will be the end area, so once again I'm using a different tile specifically for this place. Let's build the top level. Since the player won't go there won't be anything special about it. That will be it for this video. In the next one, we will continue to implement the models. See you! This is the final video of this section. We will finish the level design in this one. So let's continue. Let's play the level and see what we have done so far. It seems like the doors are closed. I will remove them. And we can actually get stuck in here. Let's fix both of these issues. Also, it seems that I forgot about the TV in the room. I'm just gonna disable the doors here. And there are some pipes, which we can use to block this hole. Now this wall does not fit, so I'm just gonna replace it with a regular wall. Everything seems fine. Now let's add the key card and the ladder. I will download the free ladder model from the asset store. It seems like it has some colliders. We won't be needing them, so I will just delete them. It looks like the ceiling is not high enough for the ladder. Let's fix that. Yep, that's pretty good. Just out of the player's reach. And that is pretty much it. The player will start the game, read the message on the TV in her room, pick up the keycard to exit the room, and see the ladder as she exits the room. If she pays attention to her surroundings, she will discover the secret over here. Finally, she will use the console to lower the ladder, jump down from here, and exit the room. The jumping down part is actually quite important. You don't want for the player to backtrack if nothing has changed, or there is nothing new to see on the way back. It wouldn't be a problem for our level, but it is something to keep in mind when building larger levels. That will be all for this section. Now you have a playable level on your hands. As an exercise, build an adjacent room, if you haven't already, add a couple of story elements, and a secret for the player to discover. In the next section, we will write the code and make our game work. See you then! In the previous sections, you have learned pretty much everything you need to know to design a level. Now it is time to make it actually work. As I mentioned at the beginning, it is not a C# course, and I won't teach it to you from the ground. I assume that you have a beginner level knowledge about the programming, and at least you know what a variable and the functions are. That being said, it is not going to be an advanced course either. The things we are going to do here will be relatively simple. So without further ado, let's create our first script. For the sake of being organized, create a folder inside the assets and call it scripts. Open it up and create a new C# script and call it test. If you select the script, you will see what's in it in the inspector window. However, you cannot edit it from here. So double click on it, and if you installed the Visual Studio before, it will open up. If not, Unity will open up the MongoDevelop instead. Don't worry though, for our purposes, they both function in the same way. But I will assume that you have installed the Visual Studio. After the Visual Studio opens up, you will see this script. In the first few lines, there are a few using statements. These are the declarations of libraries we are going to use in the script. If it is grayed out, it means that we are not using the specific library in this script, and you can remove it. But let's leave them as they are. Next, there is the definition of the class. You can tell by the colon sign that it is inheriting from the MonoBehavior class. Inheritance enables you to create new classes that reuse, extend, and modify the behavior that is defined in other class, meaning that it will behave like a MonoBehavior class, which contains most of the Unity-specific functions. Speaking of which, start and update are two of those specific functions, and probably the most used ones. Let's take a look at the update first. This function is called eachFrame. To test it out, write debug.log update function and switch back to the editor. If you press play now, nothing will happen. The reason is that we didn't add the script to the scene. Create a new game object and add the test script either by drag and dropping or by clicking the add component and searching for the script. Press play and pay attention to the console and you will see the output over there. Turn on the collapse to collapse all of the same messages to a single line. You can double click on the message to open it up in the script. Click clear to remove all of the messages from the console. You probably realized that we add the test script just like we added the other components like colliders. It is because those are mono behaviors too. Most of the scripts you will be using in the game will derive from the mono behavior and you will add them to the objects in the scene just like you did with the test script. Now disable the script by clicking on the tick over here and press play. Notice that we are not getting the update function message anymore. The reason is that the update function is not being called when the component is disabled. Enable it and you will see that the message is being printed again. Let's take a look at the start function. As the name suggests, this function is called during the first frame after the script is initialized. Think of it as the first update. And it is called only once. Write debug.log start function, go back to editor, enable the script, clear the console, and press play. Stop the game and take a look at the console. As you can see, the start function was called only once and it was called in the first frame. Stop the game, disable the script, and you will see that the start function is not being called. Just like the update, it is not called if the script is not active. Now let's take a look at the awake function. Write void awake somewhere in the script and add another debug log function inside it. This function will be called even if the script is disabled. Go back to the editor, disable the script, press play, and see that the message is printed to the console. Now pause the game either by clicking on the pause button at the top or pressing Ctrl-Shift-P keys on the keyboard at the same time. Enable the script and click on the step button to skip to the next frame. See that the start and update functions were called in this frame. Check out the execution order of all of the mono behavior specific functions in the documentation. Get used to this page, you will be using it a lot. Don't worry though, Unity's documentation is pretty good. As you can see, there are a lot of Unity specific functions. We will go only through the most relevant ones. And that will be it for this video. We will continue with the Unity specific functions in the next one. Bye! In the previous video, we checked out a few of the Unity's functions. In this one, we will continue the discussion on the most used Unity-specific functions. Let's start with the onEnable function. This one is similar to start. The difference is that it is called each time the script is being enabled, while the start is called only once during the script's lifetime. So add the function to the script, add the debug log message, and return to the editor. Collapse the messages to better see them. Disable the script and press play. As expected, only the awake function was called. Now enable the script and see that other messages are being printed as well. Disable the script and the update messages will stop. Now clear the console, enable the script once more. Notice that this time the start and awake functions were not called, but only the enable function was. The onDisable function is similar to onEnable, but as you can tell from the name, it is called each time the script is being disabled. The late update function is called each frame after all update functions have been called. Fixed update is the frame-independent version of update. It has the frequency of the physics system. You can change its frequency from the editor. Go to the Edit, Project Settings, Time. Here you will see the fixed timestamp value. The default value is 0.02. For the most time, it is good enough. Use this function for the physics calculations. Now let's take a look at the onCollision functions. There are three of them: onCollision enter, onCollision stay, and onCollision exit. The names are pretty self-explanatory. These functions are called when a collision has happened, ended, and during the collision itself. To test it out, let's create a cube. Reset its position and change its scale to 10.110. It will be the floor. Now create a sphere and position it above the floor. Make sure that the camera sees the sphere. For the collision function to be called, at least one of the colliding objects has to have a rigid body component. And obviously, both of them has to have a collider component. So add the rigid body component to the sphere, add the test script to the sphere, and open up the script. Add the onCollisionEnter function and the debug log message to the script. Play the game and see that the collision message is printed as soon as the sphere hits the floor. Usually, we want some more information about the collision, like the objects involved. To get that information, add an argument of type collision to the onCollisionEnter function. This argument will give us the information about the objects we just hit. Let's print out the name of the object. Add call.transform.name to the message string. Play the game, and you will see that the object we just collided into is called cube. The rest of the onCollision functions works in the same way. The onTrigger functions are similar to onCollision functions, but they work with the triggers. The difference is that the triggers do not try to resolve collisions, meaning that an object can pass through them and they will notify us via onTrigger functions. So let's create another cube. I will call it Trigger Cube. Mark the box collider component as trigger and put it between the sphere and the ground. Press play and notice that the sphere passes through the trigger cube and we don't get the collision message for the cube. Now go to the Visual Studio and add the onTriggerEnter function with the message, and you will get the message as soon as the sphere enters the trigger cube. To get the information about the trigger, add a collider argument to the function. To test it, add call.name to the message. And these are the most used Unity functions. We will make use of most of them in the following videos. In the next one, we will see how we can use triggers and colliders in our game. See ya! In the previous videos, we learned some of the Unity-specific functions. Now let's see how we can use them in our game. First, let's add a trigger area to the glass door of our bedroom. Open up the prefab, add a box collider, mark it as a trigger and make it a little bigger. It will detect the player when the player gets close to the door. Now create a script and call it door. Add it to the prefab and open it in the Visual Studio. Delete the start and update methods. We don't need them now. Add the onTriggerEnter method with a message. Play the game, and as soon as you enter the trigger area, you should see the message in the console. Let's add onTriggerExit function as well. We want the door to open as soon as the player enters the trigger and close as he exits it. So let's write a function that does just that. I will call it openClose. Also, we will have two variables for open and closed states of the door. So define two public vector3 variables and call them openRotation and closedRotation. Then define one more private variable and call it desiredRotation. The openClose function will always rotate the door towards the desired rotation. We will set the desired rotation to openRotation as the player enters the trigger area and to closedRotation as he exits it. We want the door to be closed at the beginning of the game, so add the start function and set the desired rotation to closedRotation. To rotate the door object, we need to know what object is that. So define one more public GameObject variable and call it doorObject. Now inside the openClose function, let's set the rotation of the door object to desired rotation. To do that, write doorObject.transform.localRotation equals quaternion.Euler desired rotation. So here's the thing. Unity and pretty much every 3D software does not use Euler angles. Instead, they use quaternion angles. Since quaternions are hard to understand, we use Euler angles and convert them to quaternions using quaternion.Euler function. Now that you have our function, we need to call it somewhere. And we will do it in the update function. So add the update function to the script and call the openClose function from the update. And finally, we need to set the desired rotation to openRotation whenever the player exits it. So just add those lines to the respective functions. Go back to the editor, wait for the scripts to be compiled, and notice that all of our variables are there. Enable the door object, if you haven't already, and note down its rotation. It will be the closedRotation. Toggle the handle position to pivot and open the door by rotating it. Again, note the rotation. It will be open rotation. Select the parent object and set the rotation. For me, the open rotation was 0, 90, 0, and the closed rotation was 0, 0, 0. Drag and drop the door object to the door object field. If you play the game now, it won't work. But don't worry, it is not because we did something wrong. The problem is that this object has an animation playing, and the animation sets the rotation of the door to 0, 0, 0. Just remove the animator component and it should work. And yes, using animations is another method to move around the objects. So technically it works, but it doesn't look very good. Let's rotate it with time. To achieve that, we will make use of the linear interpolation function, or lerp for short. This function takes three arguments: the initial number, the final number, and the interpolation percentage. In our case, we will have initial vector 3, final vector 3, and the interpolation percentage. It will look like this. This is long, so let's break it down. Vector3.lerp is the linear interpolation function for two vector3 variables. We want to interpolate between the current rotation of the door and the desired rotation. As I mentioned before, Unity holds the rotations as quaternions, so we cannot use the local rotation. We need to use local Euler angles instead, which is the first argument. The second one, obviously, is desired rotation. Time.delta time is the time passed between two frames. If your game runs at 60 FPS, time delta time will give you roughly 0.016. So each frame, you will get that much closer to the desired rotation. Try it out and see that it works. It rotates pretty slow though. So let's add another variable to control the speed. It will be a public variable and I will call it OpenSpeed. Multiply time delta time with the OpenSpeed and try it out. Yep, it looks good. Now we can change the OpenSpeed variable directly from the editor. That will be all for this video. In the next one, we will add some more interactions using triggers and colliders. See you then! In the previous video, we wrote a function to open up and close the door. Now we will make use of the layer and colliders to create even more interactions. First, we need some kind of a hand to interact with stuff. Open up the FPS controller prefab and add a box collider to the camera. The camera component is on the first-person character object. Change its shape and mark it as a trigger. If you play the game and enter the trigger area of the door, you will notice that the trigger detects the new box collider as well. We don't want that. There are a couple of ways we can avoid that. We can check the type of the collider from the script and stop the execution of the function if it is not the player. This way may be preferable in some situations. But for this specific case, there is a better solution: using layers. If you open up the physics settings from Editor, Project Settings, Physics, and scroll down, you will see the layer collision matrix. This matrix determines which layers can collide and which cannot. For example, we probably don't want for the water to collide with the UI elements, so we can disable the collision between the two. Let's create a couple of new layers. Go to the Tags and Layers menu and open up Layers. We need a layer for the player's hand and probably for the interactable objects as well. So let's add them. Go back to the layer collision matrix and you will see the new layers. Disable all collisions except the ones between interactable and hand layers. Also, the interactables might need to interact with the rest of the world, so you might want to leave the collisions with the default layer as well. Close this window, select the first-person character object, and from the layer drop-down menu at the top of the inspector, set the layer to hand. Play the game, and since the door is on the default layer, the first-person character won't collide with the door trigger area. Now let's create a player script to interact with the interactable objects. Open up the FPS controller prefab, add the script to the first-person character, and save the prefab. Also, set the layer of the keycard to interactable so we have something to interact with. Open up the script and add the onTriggerEnter function with a message. Play the game, and when you look at the keycard, the message will pop up. It looks like the collider can be slightly higher. That will be it for this video. Next time, you will learn how to get input from the user, and we will make a simple inventory system. See you! Now that we know the basic Unity functions and how to utilize some of them, let's get input from the user. So let's print out a debug message whenever a player hits a button. The button will be E, since it is assigned as a use button most of the time. Add the update function to the script, and inside the update write if input.getKey keycode.e debug.log player pressed E. Save it, open up the editor, and try it out in-game. You will see the message printed as long as you hold the key. As you probably have guessed, input class gives us the information about the input. In this specific case, we asked if player is pressing E key. The getKey function will return true if the specific key is being pressed. But what if we want to execute the code only once when the key is pressed? Well, we can use getKeyDown instead of getKey. Let's play the game and see what happens. See, no matter how long you're pressing the key, you only get one message. GetKeyUp works similarly, but as you can tell from the name, it returns true only when you release the key. To get input from the mouse, you can use input.getMouseButtonDown. As an argument, you will have to pass the index of mouse button. 0 is the left button, 1 is the right, 2 is the middle, and so on. Now let's try and click on interactable objects. First, we need to know if we are looking at one. So let's define a private game object and call it looking at. In the update, we will use getKeyDown function and we will print the message only if we are looking at the interactable object. We will set the onLooking object in the onTriggerEnter function and set it back to null in the onTriggerExit function. Try it out, and after you see the Start Looking At message, you should be able to click on the object and Looking At message should pop up. We want each object to react differently when we click on them. We want to be able to pick up the keycard and put it in the inventory. And when we click on the TV or console, we want to get the message. To do all of that, we will create a class which we will use as a base, then we will derive a TV and key classes from that base class. So go to the editor to create a new C# script and call it interactable. Open up the script, remove both update and start functions, we won't need them. Write a public virtual function and call it interact. It is important that this function is virtual because it lets us to override it from the classes derived from this one. Let's print out the message whenever this function is called. Go back to the player script and change the type of the looking at object to interactable. In the onTriggerEnter function, change other.gameObject to other.getComponentInteractable function. The getComponent function will search for the specified component on the game object and return the first one it finds. If no components of this type are found on a given object, then it will return null. Similarly, in the onTriggerExit function, we can check if the object that just left the trigger area has the interactable component on it, and if that component is the same one we are currently looking at, and only then set the looking at variable to null. Finally, in the update function, instead of printing out the message, we can call the interact function on the looking at object. Go back to the editor and add the interactable component to the keycard. Try to interact with it and you will see the interacting with message. Now let's create a specific keycard class. Create a new C# script, call it keycard, open it up and change the monoBehavior class with the interactable. Override the interact function by writing public override void interact and print out the message saying override of the interact function. Go back to the editor, remove the interactable component from the keycard, and add the keycard component instead. Play the game, and you will see the new message. If you want to call the original interact function, you can do it by writing base.interact. Finally, let's do the same for the TV. But this time, let's add a custom message so we don't have to create a new script for each TV in the game. The only difference will be that the TV class will have a public string. I will call it message, and it will print this message instead of the hard-coded one. And this is it for this video. We will create a simple inventory system in the next one. Bye! Now that we know how to interact with objects, let's continue with the inventory system. First, we are going to need some kind of list to hold interactable objects. Luckily, System Library has just that under the system.collections.generic namespace. So add it with the using statement if you haven't already. Then define the list of type interactable and call it inventory like this. Now we need a way for interactable object to add itself to inventory whenever we interacted with it. The easiest way is to pass the player component as an argument to the interact function. So modify all of the interact functions to accept player object as an argument. In the keycard script, access the player inventory by simply writing player.inventory and add this component by writing .add this. From the player script, pass this as an argument to the interaction function. In both cases, this means that specific component. And that should be it. Go back to the editor, check out the player component, and you should see the inventory list. Right now it has 0 elements. Play the game and interact with the keycard. Check out the inventory in the player component and you will see that the keycard was added to the list. We don't want the keycard to remain on the desk though. So let's disable it after we pick it up. Open up the keycard script and add the game object setActive false line right after adding it to the inventory. Try it out and you will see that the keycard indeed disappears. However, press the interaction key one more time and you will notice that we have a bug. The keycard was added again. The reason is that if you disable a game object, it does not fire up the onTriggerExit function. There are many ways in which we could prevent this bug and many other solutions for the inventory system, but we will have to do a much longer course to cover them. So as a quick solution, we can check if the game object is active whenever we click on it. To do that, add another if statement before interacting with the object and check if the interactable is active. Set it to null if it is not. Now that we have the keycard, let's modify the door to open only when we have the keycard. Open up the script and add a private player object and public interactable object and call it keycard. In the onTrigger method, first set the player object using getComponent function. Then check if the player is not null and if it has the keycard in the inventory. Open up the door if both are true and print out a message otherwise. Go back to the editor, select the door, and lock the inspector with this little icon at the top. Now the inspector window won't change even if you select another object. Find the keycard, drag and drop it to the keycard field, and don't forget to unlock the inspector. Play the game one more time, and you will see that the door does not open unless you have the keycard. Now let's make the ladder come down when we interact with the console on the second floor. First, create a new script and call it ladder. Open it up and define a public vector tree and call it final position. We will add a familiar line to the update method. Transform.localPosition equals vector3.lerp transform.localPosition final position time.deltaTime. We want to use the local position instead of the global position because we want it to move relative to its parent. Also, let's define a public float. Call it drop speed and multiply time delta time with it so the ladder falls faster. Add the script to the ladder object and set the final position just like we set the rotations for the door. Put the ladder back to the original position. If you play the game, you will notice that the ladder falls down right away. The reason is pretty obvious. We moved it in the update method. To avoid that, just disable the script and we will enable it when we need the ladder to come down. Create one more script and call it console. Open it up and inherit from the interactable. Define a public ladder object. Override the interaction method and enable the ladder script with the ladder.enabled equals true line. Add the script as a component to the console, set the ladder, and you are good to go. Finally, let's inherit the ladder from the interactable class, override the interact function to print out the game over message, and add a collider to the ladder so we can interact with it. And that is it. Congratulations! You have a fully playable game. In the next video, we will create a simple message system. See you! In the final video of this section, we will create a message system to make our lives easier in the long run. Basically, we will have a class that will take care of printing out the messages. Right now, we can print whatever we like using the debug.log function. But what will happen when we have a UI system? In the current state, we will need to have a reference to the specific UI class which brings the message to the screen. And what if you want different messages to be sent to different classes? Well, the messenger class will take care of that for us. So we will only need a reference to that class. What happens after we ask the messenger to deliver the message won't concern us. So create a new script and call it messenger. Open it up, delete the start and update functions. Write a new public function and call it display message with a string argument called message. For now, we'll display the message using the debug log, just like we did before. Now, if you want to print a message using this function, we need to have a reference to the messenger class. We can define a public messenger variable in each class we want to call it from, then drag and drop the messenger object from the hierarchy, just like we did with the ladder in the console class and with the door object in the door class. But it is too much work and not always convenient. Instead of dragging and dropping, we can search the scene for the messenger using findObjectOfType function in the awake. Or even better, we can use the singleton pattern. The singleton pattern ensures that the class has only one instance and provides a global point of access to it. What it means is that this pattern ensures that we have only one messenger object and we can easily access it without need of searching for it each time. We will slightly simplify the pattern for this course and skip the ensuring single instance part. But keep in mind that it won't work correctly if you have more than one messenger components in the scene. So open up the messenger script and define a private static messenger variable and name it instance. Static modifier means that this member does not belong to a specific object, but to the type itself. For our case, it means that we don't have to find the messenger object to access this member. Instead, we can access it just by typing messenger.instance. Well, right now we can't, because it is a private member. But we could if it was a public one. To fix that, let's write a public static method. It will return a messenger, and we will call it instance with the capital I. This method will return the instance, but first we need to set it. Let's check if the instance is already been set. If not, we will search for it in the scene using findObjectOfType function. And that is the basic version of the singleton pattern. We can simply write messenger.instance whenever we want to access this object. As I mentioned before, it assumes that we only have one object of this type in the scene. So let's modify the scripts to use the displayMessage method. Open up the interactable script and change the debug.log line with messenger.instance.displayMessage function. Do the same for every message you wish to display in the UI. Create a new game object in the scene, name it Messenger, and add the Messenger component to the object. And that will be it for this section. Now that we have a functional game on our hands, we will move on to the UI system. As an assignment, try to add a couple more puzzles like the keycard and a story element or two. See you in the next section. Welcome to the 6th section of the course. By now, we have built our game and it is fully functional. The only missing part is the user interface, or UI for short. For the majority of the games, UI is pretty important. In some cases, like 4X strategy games, UI can make or break the game. It is true that sometimes it is possible to create an awesome game without using a single UI element. But it is a pretty hard task. And we definitely want it for our game. So without further ado, let's start. Create a new scene to not mess things up in our game scene. Right-click in the hierarchy and from the UI select Canvas. All UI elements should be inside the Canvas area. The Canvas is a game object with a Canvas component on it, and all UI elements must be children of such a canvas. If you can't see the canvas, don't worry. Select it from the hierarchy, move the mouse cursor to the scene view and press F to focus. Yeah, it's huge. See these values over here? These are units. Just create a cube, reset its position, and focus on it to see how big the canvas is. Basically, each unit corresponds to a single pixel. So this rectangle actually represents the in-game camera. Focus on the canvas once more, dock the game view next to the scene view, and observe how the size of the canvas changes with the size of the game view. Dock the game to its old position, and let's take a look at the components in the canvas object. One of the key differences with the regular game objects is that UI elements uses rect transform instead of a transform. The rect transform component is the 2D layout counterpart of the transform component. Where transform represents a single point, rect transform represents a rectangle that a UI element can be placed inside. Right now, we cannot modify it, so we will return to this component later on. The second and most important component of this object is the canvas itself. The render mode setting can be used to make it render in the screen space or world space. The screen space overlay render mode places UI elements on the screen rendered on the top of the scene. If this screen is resized or changes resolution, the canvas will automatically change size to match this, just like it was changed when we docked the game view next to the scene view. Screen space camera is similar to screen space overlay, but in this render mode, the canvas is placed at a given distance in front of the specified camera. Set the camera using this field. In the world space render mode, the canvas will behave like any other object in the scene, meaning you can have in-world UI elements. We will make use of it in our game. Select Screen Space Overlay mode and let's continue. The Pixel Perfect option will force elements in the canvas to be aligned with pixels. This won't work in the World Space Rendering mode though. Sort Order is the order in which canvas will render. A canvas with a higher order will be rendered on top of the one with the lower order. Target Display is the display on which the overlay canvas will be rendered. The canvas will always include necessary shader channels, but in case you want to set extra ones, you can do it using this menu. Switch to World Space. The event camera over here is the camera that will be used to process the UI events like clicking and dragging. Also, you can set the sorting layer while in this mode. Switch back to the overlay mode or camera mode and let's take a look at the canvas scaler. This is a pretty important component. It will help the UI elements remain in their correct places regardless of screen resolution. The UI scale mode determines how UI elements in the canvas are scaled. Constant pixel size makes UI elements retain the same size in pixels regardless of screen size. Scale with screen size makes UI elements bigger the bigger screen is. Constant physical size makes UI elements retain the same physical size regardless of screen size and resolution. Scale factor scales all UI elements in the canvas by this factor. Reference pixel per unit is not a very important thing, so I'm gonna skip it. Scale with screen size mode is the most useful one in my opinion. Set the reference resolution to whatever resolution you are planning to design the UI for, and Unity will resize it to fit any kind of screen. Screen match mode is used to scale the canvas area if the aspect ratio of the current resolution doesn't fit the reference resolution. Match determines if the scaling is using the width or height as a reference, or a mix in between. Graphic Raycaster is used to raycast against the canvas. Without it, a user won't be able to click on the UI elements under this canvas. Ignore reversed graphics determines if the graphics facing away from the raycaster should be considered for the raycasting. You can set some objects to block the raycast to the UI elements using blocking objects and blocking mask options. And that will be it for this video. In the next video, we will continue with the UI elements. See you next time! In the last video, we began to examine Unity's UI system, and we will continue in this one. The next element we will be looking at is the panel. Right-click on the canvas, and from UI, select Panel. This is a pretty simple object. It contains a canvas renderer component and an image component. The canvas renderer component renders a graphical UI object contained within a canvas. The Cal Transparent Mesh option indicates whether the geometry emitted by this renderer can be ignored when the vertex color alpha is close to 0 for every vertex of the mesh. The image component displays an uninteractive image to the user. Set the image you would like to display using the source image field. However, keep in mind that it only accepts sprite images. Find an image from the project, set its texture type to sprite, then just drag and drop it to the source image field. You can set the color to apply to the image using the color field and the material using the material field. Disable the raycast target option if you don't want this image to block the raycast from mouse clicking. The simple image type will just display the image as it is. To prevent the image from stretching, use the Preserve Aspect option. Set Native Size button sets the dimensions of the image box to the original pixel size of the texture. Tiled image type will tile the sprite according to the wrap mode settings in the image importer. Change the source image to the background by clicking on the picking tool and searching for it. Select the filled image type. This one fills the image by the fill amount. There are few fill methods, and all of them are self-explanatory, so I'm skipping them. The last image type is the sliced. Select it, and you will notice that the sprite preview is divided into 9 areas. When using the sliced image type, the corners of the sprite, as defined here, won't get stretched. The middle left and middle right will only stretch vertically, middle top, middle bottom will be stretched horizontally, and the center will stretch in all directions. Keep these rules in mind and you can draw a single bottom background for almost every size. Remove the center by turning off the Fill Center option. To set these boundaries, select an image, set the texture type to sprite, click Apply, and click on the Sprite Editor button. Drag these green lines, or set the border values directly to set the sliced sprite image. Click Apply, close the Sprite Editor, and the sprite is ready to be used as the sliced image. Now let's take a look at the Rect Transform component. This thing over here shows the anchor presets. Right now, it is set to stretch to fit to the parent object. Set the borders using left, right, top, and bottom fields. Change the anchor preset to middle one. Now the UI elements won't scale with the parent. Change its size using width and height instead. Now that we set the anchors to the middle, the position of the panel is set relative to the middle of its parent. You can use any of the presets to position the UI elements as you like, or manually set the anchors. Let's move on to the next element, the text. Right-click on the panel and select the text from the UI. Notice that there are two types of texts, the regular one and the Text Mesh Pro. The Text Mesh Pro is actually a more advanced version of the text. But for the sake of simplicity, we will move on with the regular one. However, I strongly encourage you to learn Text Mesh Pro as well. The text field is where we write our texts. Font, font style, font size, and line spacing are pretty much self-explanatory. Rich text allows you to use some HTML tags like colors. Horizontal and vertical overflow options are used to determine what happens to the text if it does not fit horizontally or vertically. Turning on the best fit will change the font size to fit inside the text tract. Finally, let's take a look at the button. Create a new one under the panel and select it. If you would like to disable the button but still keep it in the UI, turn off the interactable option. To give the user feedback whenever he or she moves the cursor over a button or click on one, you can use the transition. The default mode is the color tint. Set the colors and the image you want to apply the colors to, and you are good to go. You can swap the visuals or use animation as well. Navigation is used to navigate between the UI elements using the keyboard, but we are not going to need it in this course. To set what happens when the user clicks on a button, use the onClick event. Click on the plus button, drag and drop an object which contains the component you are interested in. Click on the drop-down menu, and you will see the list of the components of that object. From a component, you can choose what function you want to invoke and pass one argument. For example, select the game object and select name. Write anything as an argument. Run the game, click on the button, and you will notice that the name of the game object is changed to the one you just passed as an argument. We will explore its functionality further in the following videos. And these are the most important UI elements we will be using in this course. The rest is quite similar. You can figure out how most of them work just by playing around with them. In the next video, we will see how we can use them in our scripts. Bye! In the previous videos, you have learned how to create UI elements and what the components do. Now let's see how we can manipulate them with scripts. So let's begin by creating a script. Open it up and add using UnityEngine.UI line at the top. Then, define a public field of type text and call it something like test text. Now let's change the text when the player presses the space key. Get the input with the if statement, just like we did in the previous section, and add the test text.text equals space key is pressed line inside. Save the script, go back to the editor, create a new game object, and add the test UI script to that object. Find the text object we created in the previous video and drag it to the test text field we just created. Play the game, and as soon as you press the space key, the text will change to the string we defined in the code. Now let's do the same thing with the button. In the previous video, we changed the name of an object with the onClick event. Similarly, we can drag the text component to the event field. From the text component, select the text and write whatever you want for the text to be. Run the game, click the button, and the text will change. Now let's do the same with the text UI component. Go back to the Visual Studio and add a new public function, call it changeText, and write testText.text equals click inside. Go back to the editor, drag the test UI object to the field, and just as we did before, select the changeText function. Play the game, click the button, and see the results. But what if you want to add a callback for a button in the runtime? Maybe we're creating the UI on the fly, depending on the item count the player character has. That is easy enough to do. Remove the onClick event from the editor by clicking on the minus sign, open up the script, and add another field after the test text. It will be a public button, and I will call it test button. Add an awake function and write the following line: test button.onClick.addListener change text. In that line, onClick is a Unity event. You can think of events as a kind of an array which stores functions. Using addListener, we have added the changeText function to the onClick list. The function in this case is called a listener. Basically, Whenever an event is invoked, it calls all of the functions that are registered to it. So whenever we click on the button, the onClick event will be invoked, invoking all of the registered functions in the process. If no function is registered, then nothing will happen. And you can register as many functions as you like. You can even register one function twice, and it will be called twice. Save the script, go back to the editor, and try it out. One thing to keep in mind here is that this function will still be called even if you disable the test UI script. At some point during the game, we might want to remove a function from the event so it is not called anymore. To do that, you have to use removeListener function. To demonstrate it and repeat what we have learned so far, let's register the function to the event whenever the scripts are enabled and removed whenever it is disabled. Also, change the text each time we press space key to space key is pressed, and when we click the button, to button is clicked. Open up the script and remove the awake method. Instead, add onEnable method, add the change text function as a listener to the onClick event of the test button, and change the test text to change text registered. Add onDisable method, remove the change text function from the onClick event, and change the test text to change text unregistered. Play the game to test it. First, you will see the text on the screen is set to the change text registered string, because the onEnable function was invoked. Click on the button and the text will change to button click. Press space and you will see the space key pressed string. Disable the script, see that the text changes once again. It should say change text unregistered. Right now nothing will happen if you click on the button, because the change text function was removed from the listeners of the onClick event. Pressing space also will not work because the update function is not being called while the script is disabled. Enable it and all of the buttons will work once again. These are the basics of manipulating the UI with scripts. And that is all that we are gonna need in this course. In the next video, we will implement this UI system to our game. See you then! So far in this section, you have learned Unity's UI system and how to use it. Now let's implement it in our game. Open up the game scene, create a new C# script and call it UI Manager. Open it up and make it a singleton, just like we did with the messenger. Declare a private static UI Manager field, call it instance, then write the public static function which will search the scene for the UI Manager. Assign it to the instance and return the instance. In fact, since our project is quite small, it will make more sense to move the messenger's functionality to the UI Manager class. That will remove some complexity from this project. So add the display message function with the string argument to the UI Manager. Save it, open the editor, and delete the messenger class. After the project is recompiled, you will see error messages in the console. These are quite handy. Click on any of those and the script in which the error is occurred will be highlighted. In the message, you can see the name of the script, the line, and the position of the error, and the error itself. Not surprisingly, the error says that the name messenger does not exist in the current context. Double-click on an error and it will take you to the exact line in the script. To fix it, replace the messenger with the UI Manager. Go back to the editor and repeat the same process for all of the errors. Finally, delete the messenger game object from the scene and create a panel instead. When you do that, notice that Unity automatically created a canvas and made the panel its child. It does that because in order to render any UI element, we have to have a canvas as its parent. Also, notice that Unity has created another object, called Event System. It has two components on it, Event System and Standalone Input Module. Both of them ensures that the UI works correctly. The Event System registers mouse clicks on the UI elements, while the Standalone Input Module registers the keyboard inputs. Add the UI Manager script to the canvas object, rename the object to UI, and rename the panel to In-Game Panel. From the canvas scaler, set the UI scale mode to scale with screen size, and set the resolution to 1920 by 1080. Switch to the game view and you will notice that the screen turned gray. It is because the in-game panel is stretched to fill the screen and has a background. We don't want it right now, so just remove the image component from the panel. Right-click on the in-game panel object and create another panel. Make sure the new one is a child of the in-game panel. This one will be the message panel. We want it to be at the bottom of the screen, so let's change its anchors. You can adjust the size and position of the panel by directly modifying the rect transform, just like a regular transform. Or you can use the rect tool. Switch to the scene view, switch to the 2D mode by pressing this toggle, focus on the message panel by pressing F, and select the rect tool either by clicking on it or pressing the T key on the keyboard. And now you can easily resize it and move it around. Hold the Shift key on the keyboard to keep the aspect ratio while resizing. I like round numbers, so I will use the rect transform component after I roughly placed it where I want it to be. Switch back to the game view to see how it looks. Yep, it will work. Now let's add the text component. Switch to the scene view to see its boundaries. Let's make it bigger. We can just resize it as we did with the message panel, but we want the size of the text boundaries to be relative to the message panel. So change the anchors to stretch in all directions. Again, we can manually adjust the positions of each of the sides, but luckily, there is a shortcut for that. Click on the anchor presets, hold the Alt key, and click on the stretch in all directions preset. The font size is pretty small, so let's make it bigger. 40 will do. Also, most likely, we want it to be in the center, so let's change the alignment. Looks good enough. Now let's move on to the scripting. Open up the UI Manager, add the Using Unity Engine.UI line to the top and add a public text field and call it message. Change the argument of the display message function to MSG so we won't confuse them. Delete the debug log line and write message.text equals MSG instead. Save the script, go back to Unity, drag the text object to the message field, and we should be good to go. Let's test it. Yep, it works. But it seems that I forgot about the need a keycard message. So open up the door script, and instead of the debug.log message, write uimanager.instance.displayMessage need a keycard. Okay, great. But probably we want for the message to disappear after a certain amount of time. So let's do that. Open up the UI Manager script and add a private float named message_timer, set it to 0 by default, and add a public game object named message_panel. In the update, we will check if the message timer is smaller or equal to 0, and disable the message panel if it is the case, or decrease the message timer by time delta time otherwise. Add another argument to the display message function. It will be a float, we will call it msgTime, and set it to 3 by default. It means that if we don't specify this argument when we call this function, the value will be assumed to be 3. Set the message time to msgTime. Finally, we want to activate the message panel each time we got a message. Go back to the editor and set the message panel field. And it works. And that will be it for this video. In the final video of this section, we will add some indicators to help the player out. See ya! Welcome to the final video of this 6th section. In the last one, we begin to implement the UI system to our game. We will finish it up in this one. Right now, we're delivering the story through the TVs or consoles. So we may assume that the messages we will get from the TVs will be really long, and we want them to stay on the screen for a longer time. Open up the TV script and add 10 seconds as an argument to the display message function. Or even better, define a new public float, call it message time, and pass it as an argument so we can adjust the time for each TV separately. Find the TV in the bedroom and set its message to something long and the time to 10 and try it out. Great! Also, we probably want to let the player know whether she has something in the inventory or not. So let's add an image to the in-game panel and move it to the top right corner. As a keycard icon, I will use this one. It was created by Eleanor Wong and downloaded from flaticon.com. You can use most of the pictures on that site for free as long as you credit the author. Again, don't forget to check the license before using any pictures from this site. Download it, drag it to the project, set the texture type to sprite, and then set the source image of the new image you've just created to this one. For now it will do. Change the name of the image object to keycard. Open up the UI Manager script and define a public game object named keycardIndicator. Open the player script and add a public function called addItem with an argument of type interactable and call it item. This function will add an item to the inventory list and enable the keycardIndicator game object. Open the keycard script and instead of directly adding the keycard to the inventory, pass the keycard to the addItem function. Go back to the editor, set the keycardIndicator. Disable the keycard object. We want it to enable only when we pick the card up. Check out if it works. If we were building a bigger game, we would require a more advanced inventory and a UI system. But for now, this should be enough. Now let's set the contextual indicators for interactable objects. Select the keycard and create a canvas. Make sure that the canvas is a child of the keycard. Set the render mode to world space and reset its transform. It is still very big for our purposes, so set the scale to 0.01, 0.01, 0.01 and set the width and height to 500. Change the name of the new canvas to something like Context Indicator. Remove the canvas scaler and graphic raycaster components from the canvas. We are not gonna need them. Create a text object as a child of the context indicator. Set the anchors of the text object to stretch in both directions, holding the Alt key in the keyboard. Set the font size to 100. Set the color to white and align the text to the middle bottom. Now reposition the canvas so the text appears next to the keycard. Open up the interactable script and add a public game object and call it context. Add another public virtual function and call it setContext. It will have an argument of type bool. Call it state. Inside the function, check if the context is null and set it to the given state if it is not. Open the player script and in the onTriggerEnter function, after the getComponent line, check if the looking@object object is null. Call the setContext function with the true as an argument if it is not null. Similarly, check if the looking@object object is already null in the onTriggerExt function and call the setContext function with the false as an argument if not. Go back to the editor, set the context field to the context indicator, write E as a text and disable the context indicator game object. Now let's see if it works. Yep, it's working. Let's add the same canvas to both TVs, console and the ladder. I will make it a prefab so it is easier to reuse it. I will apply these new values to the prefab. Take a look at the keycard and fix the scale if needed. Now, add the context canvas to the remaining interactable objects. And that will be it. Finally, we have a full game with UI and everything. There are a couple of things that will be great to have, like the game over screen, the pause screen, and the main menu. Try to do the game over and pause screens as homework. Disable the first-person controller component on the FPS controller object to stop the player from moving around while in the pause menu. You're probably thinking that the game is not looking that good and it does not feel quite right. And you're correct. What we are missing here is polishing, and we will talk about it in the final section. Take care until then. Greetings! This is the 7th and the final section of this course. If you made it this far, then congratulations! You have a playable game on your hands. But I bet it doesn't look and feel quite good, does it? The visuals are kind of washed out. There are no sounds, we are using the default font, which does not fit with the theme, etc. Sure, the game is playable, but it's pretty rough around the edges, isn't it? Well, don't worry, this is what this section is all about, polishing the game. Have you ever played the game and thought that it didn't feel quite finished? Perhaps there were too many bugs, or perhaps some textures were ugly or seemed out of place. And maybe you almost enjoyed the game, only if the controls were better. Well, in that case, the chances are that the game was not polished enough. According to the Merriam-Webster dictionary, polish means 1. To make something smooth and glossy, usually by friction. 2. To smooth, soften, or refine something in manners of condition. 3. To bring to a highly developed, finished, or refined state. Mainly, we are talking about the third definition here. The polishing will make or break your game. I know I said the same thing about the UI, and creating a nice, usable, and easy to understand UI is a part of the polishing process, but you can build a game without the UI. And in most games UI is not as important as, say for example, shooting in a first-person shooter game or jumping in a platformer game. Everything in a game should feel natural, and the player should not think about the controls or UI during the gameplay. It is not possible to make a checklist for polishing. There are no techniques or formulas to apply to every single game. Each game is unique in this sense. So I will talk specifically about our game. The most obvious things that are missing from the game are the main menu, pause menu, and the game over screen. If you did the assignment, then the pause menu and the game over screen should be taken care of. If not, don't worry, I will create them in the following videos. The next thing we should fix is the player movement. Right now, the character moves too fast, can run and jump. It does not fit to our game. With an exception of the footsteps, we have no sounds at all. Of course, usually we implement them before the polishing begins. But there is not much to talk about, so I left them for this section. Next, we will take care of the lighting. We really need to pay attention to the lights if you want to create a nice atmosphere. And they really help to set up the mood. I will be adding more details to the environment during this stage. Then, going back to the UI, we will find a nice font that fits the theme of the game. I will add a short story in this part. Finally, we will take a look at the post-processing. Think of Instagram filters and you will get the idea. Some subtle effects can dramatically improve the visual quality of a game. And I think that will be it. I hope I was able to explain what the polishing is and demonstrate its effect. In the next video, we will begin to polish our game, and at the end of this section, we will have a very nice and polished short walking simulator. See you in the next video. In this video, we will begin to polish our game. Let's start with the missing UI elements: pause menu, game over screen, and the main menu. For the pause menu, we need a new panel. Create one under the UI and call it pause panel. We don't need a background image, so remove the resource image by clicking on the picking tool and selecting none, or by clicking on the background field and pressing the delete key on the keyboard. I want the game itself to be slightly visible, so I will set the color to the black and the alpha value to something like 200. Open the UI Manager script and add two new public game object fields: in-game panel and pause panel. Then, write a new public function and call it setPanel. Now, we are going to need to have some kind of identification for the panels. We are going to use enumeration, or enum for short. Enum is a distinct type that consists of a set of named constants called enumeration list. So let's create a public one outside of the UI Manager class and call it panel. We will have two panel types for now: in-game and pause. Now add an argument to the setPanel function of type panel and call it type. The function will turn the panels on and off depending on the required type. Now open up the player script, add a private bool and call it paused. Set it to false by default. Add a new public function and call it toggle pause. Inside, toggle the paused variable first and then switch to the appropriate panel. We will call this function whenever the player presses the escape key on the keyboard. So add it to the update function. Go back to the editor, set the panels in the UI and try it out. We are starting with both panels active and we don't want that. Open up the player script, add a start function and set the panel to in-game. That should fix it. Now let's disable the player input whenever we are in the pause menu. Open up the player script, add using Unity standard assets.characters.firstPerson line to the top and define a public variable of type first-person controller and call it controller. We want to enable the controller if the game is not paused and disable if it is. The line controller.enabled equals not paused at the end of the toggle pause function will do just that. Go back to the editor, set the controller and try it out. It works, but now the mouse locking is not working properly. The script called mouseLook is responsible for that. Just search for it in the Project tab and open it up in the Visual Studio. Delete or comment out the internal log update function. The shortcut to comment out a selection in the Visual Studio is Ctrl-K-C. Comment out all of the references as well. Check out if you have any errors in the editor and fix them if you do. It seems that there is one more reference in the first-person controller script. Try it out and notice that the mouse never gets locked. This is an improvement in the sense that it works in a more predictable manner. But still, it is not what we wanted. Once again, open up the player script and add the private function and call it setMouse and add a bool as an argument and name it state. If the state is true, then we will unlock the cursor using cursor.lockState equals cursorLockMode.noneLine and make it visible using cursor.visible equals trueLine. Similarly, we will lock the cursor and make it invisible if the state is false. Call this function from the pause toggle menu and pass the pause bool as an argument. Add the same line to the start so the mouse is locked at the start of the game. Okay, it still doesn't work. But this time it is not our fault. When you press the escape button in the editor, it forces the game to release the mouse no matter what. If you click on the game view after you resume the game, the mouse will get locked, and it will work in the build, so don't worry about it right now. Let's add two buttons to the pause menu, quit button and resume button. Personally, I don't like how the default button looks in the Unity, so I'll remove the background from them. Make the font bigger. Open up the UI manager and define a public function onQuit. Write a debug log message so we know that it works. We will implement it later. Right now, the player class handles the pausing. Go back to the editor, create new onClick event on the resume button, drag the player to the event field and select the toggle pause function from the drop-down menu. Keep in mind though, this is not the best way to handle it. It is okay to do it here because the project is pretty small and it is easy to track the code. But if it was a bigger project, we probably would use events or something similar. Trigger the onQuit function from the UI manager in the same way and we are good to go. That will be it for this video. In the next one, we will continue with the game over screen and the main menu. Bye! In this video, we will continue to improve the user experience by adding the game over screen and the main menu. First, let's do the game over screen. This time, we will make use of scenes. Instead of showing another panel, we will switch scenes. So, create a new scene, add a new panel, make it black, remove the background image, and add the text. Adjust the size of the text and write something dramatic. I will go with, "You survived the accident. Not everyone was so lucky." Add the button, rename it to the main menu button, resize it, and write main menu as text. Create a new script, call it Game Over, add it to the canvas. Open up the script, add a public function, call it onMainMenu. For now, write a debug log message. We will implement this later on. Set the onClick event of the main menu button to call onMainMenu function. Save the scene as Game Over and go back to the game scene. Open up the ladder script and add the using Unity Engine.Scene Management line to the top of the script, and to the interact function add the Scene Manager.LoadScene Game Over line. Switch to the editor and from File open the Build Settings window. See the Scenes in Build area? We need to add all of the scenes we want to use here. Otherwise, the Load Scene function won't work. So add the Game Scene and the Game Over scene. The important thing to know is that when the game launches, the first scene will be loaded first. It is not important right now, but it will be when we build the game. If you try to play a game now, you will notice that the mouse is not released. To release it, open up the player script, add onDisable function, and call the setMouse function with true as an argument. Try it out, and it should work. Now let's create the main menu. The main menu will be a separate scene, just like Game Over. Create a panel, make it black, and remove the background. Add the text, it will be the name of the game. You might want to put a logo instead, but for now text will do. Add the button, resize and reposition it. Change its name and the text to New Game. Do the same for the Quit button. Create a script and call it Main Menu. Write two functions, onQuit and onNewGame. To quit the game, add the application.quit line to the onQuit function. Add the scene management namespace to the top and scenemanager.loadScene game scene line to the onNewGame function. Go back to the editor and hook up the buttons. Also, you may want to add the credit screen over here, but I'll leave that part to you. Save the scene and add it to the Build Settings menu. Open the UI Manager script, add the Scene Management namespace to the top, add the scenemanager.loadScene main menu line to the onQuit function. Do the same in the Game Over script, and that should be all. Let's try it out. The Quit button won't work in the editor, but it will in the build, so don't worry about that right now. But you might want to add a pop-up window asking the player if she really wants to quit or not. And that will be it for this video. We will continue with the polishing in the next one. Bye! So far in this section, we have added some basic menus. Now let's continue with the movement and sound effects. As I mentioned in the first video of this section, the movement is not quite right. It does not fit the tone of our game, so let's fix that. First, I will disable jumping. Open up the first-person controller script and in the fixed update, comment out the if statement with mJumping argument. Also, the character moves too fast. It is easier to fix though. Select the FPS controller and in the first-person controller component, set walk speed to 3.5 and run speed to 5. The controller will take care of the rest. I find the head bobbing a little too much. So let's reduce it to 0.5 in both horizontal and vertical directions. Set the step interval to 3.5 so the footstep sounds fit the speed of the character. That's better. Now let's move on to the sounds. I have downloaded all of them from freesfx.co.uk. You can search for them by name and you should be able to find them. First, I will implement the message sound. I use the ascending beep. Open up the UI Manager script and add a public audio source variable and call it source. Add a public audio clip variable and call it message beep. Add source.play1shot message beep line to the display message function. Switch to the editor, add an audio source component to the UI, set the source and message beep fields. Make sure that the spatial blend is set to 2D and play on awake is set to false. Now, each time a message pops up, we will hear this sound. You may want to set the volume of the audio source to 0.25. Let's add another sound to the door. I will use Open Interior Wood Door sound effect for this. Set it up exactly like we set the message beep. This time we want the sound to be 3D though, so don't forget that. Also, since this is a door opening sound, we don't want it to play if the door is already open. We might want to check for the rotation, but since we know for a fact that only the y-axis is changing, checking that should be enough. So write the following if check. mathf.abs doorObject.transform local Euler angles.y minus closed rotation.y smaller than 5. As you can guess, mathf.abs gives us absolute value. If the difference is smaller than 5 degrees, we may assume that the door is closed. Adding a closing sound will be slightly more complicated. First, add a public audio clip and call it close clip. Add a private bool to the door script and call it closing. Set it to false by default. Set the closing bool to false whenever the player enters the trigger and to true whenever she exits it. In the open-close function, check if the closing is true and if the door's rotation is close to 0. If both of these are true, then set the closing bool to false and play the close clip. Now let's add a sliding sound to the ladder. I have downloaded the replace lid from the metal garbage can sound for this purpose. Since the script enables only once, we can play the sound in the start function. The rest will be the same. To better hear the sound, set the min distance in the 3D sound settings to 10. Now the sound from the ladder will get the attention of the player. Let's send the message as well. Finally, let's add an ambient sound. I will use the one called Dramatic Metallic Ambience with Drone from FreeSFX. Create a new game object, call it Ambience, add an audio source component, set the loop and play on awake options to true and spatial blend to 2D. Set the audio clip and that should be it. You may want to set the volume to 0.1. You don't want the player to pay attention to the ambient sounds. Actually, you don't even want them to notice it. It will keep them on pause on a subconscious level. And that will be it for the sounds. You may want to add a click sound to the buttons, or maybe change the default footstep sounds. But for now, it is good enough. In the next video, we will take a look at lights. Bye! So far in this section, we've created some menus, fixed the movement, and added sounds. What else is left, you wonder? My favorite part, the lights. Light is the most important component of the atmosphere. Just watch this video until the end and you will see what I mean. First of all, delete the direction light. We want a very dark environment. Better, but still not dark enough. From Window, Rendering, Lighting Settings, delete the skybox material. We're getting there. Set the source of environment lighting to color and the ambient color to black. Disable the light map generation and clear the baked data just in case. Play the game, and we've got a pitch black environment. Perfect! In most non-horror games, you rarely see a pitch black environment. Usually, designers prefer to use deep blue colors. Same goes for the cinema. But we actually want that in our game. If the scene view is pitch black as well, turn off the scene lighting toggle. Now, we want to add some light. I will use some light prefabs from the Sci-Fi asset pack. See, it already looks cool. Let's increase the range and the intensity a little, and also the color. It is too blue for my taste. Let's move on to the corridor. It seems that the material of the ladder is wrong. Change the shader to the standard, set the albedo color to white, and that should fix it. I will add 2 more lights to the narrow part, so when the player exits the room, she sees the lights coming from here. It will be a kind of signpost that shows the correct path. It looks like the lights don't cast shadows. Open the prefab and set the shadow type to soft. Also, set the bias to 0 and near plane to 0.1. The bias is kind of an offset. You can see clearly what it does if you turn the lighting on in the scene view and check out the table in the bedroom. Add a light to the ceiling in the stairs area. Now let's turn on the screens. To make them look like they are turned on, we will need to use the emission field of material. Open the prefab of a TV and add a plane and cover up the screen with it. Remove the collider of the plane, then create a new material and call it screen. Drag and drop it to the plane, enable the emission, and set the color to bright blue. See how it looks in the game and tweak if needed. Add a point light, bring it slightly in front, set the range to 5, intensity to 0.5, color to something similar to the screen color, and turn on the shadows. Do the same thing to the console on the second floor. Finally, add the screen and the light to the keycard so it stands out from the environment. Set the range to 1 and intensity to 0.5. Let's add some lights to the ladder. It will be a spotlight and we want it to shine from the second floor. It will be turned on as soon as the ladder drops down. So, add a public game object, call it projector. Set it active in the start function. Set the projector field in the editor and turn the object off. Now, when the ladder goes down, the player will hear the noise and the light will grab her attention. Finally, let's give the player a flashlight. Create a spotlight as a child of the first-person character, set its position slightly beneath the camera and move it to the right. It will be like the player holds the flashlight in her right hand. Set the spot angle to 90 and the intensity to 0.75. We want to have hard shadows on this one. I will put a couple of flowers to the corridor to make it more interesting. Let's put a couple of art pieces to the table in the bedroom. They will trigger the player's imagination. Obviously, they were important enough for our character that she put them where she can always see them. Perhaps these are trophies or awards. I will put another award to the dark corner of the second floor. But I will make it bigger so it looks like a piece of machinery. Also, let's add a seat next to the console and to the bedroom. Add a bookshelf. It being empty can tell the player that the character does not like to read. Or maybe she just moved in and didn't have a chance to bring her books with her. You get the idea. Go wild with environmental storytelling, it won't hurt. I can go on about the details in the environment for a long time. But let's just leave it as it is and move on to the next video, in which we will change the font, add a couple of story elements, and add a post-process effect or two. See you! In this video, we will continue with the polishing. First, let's change the font. This one does not fit the game at all. I downloaded a font called Zolonium from the fontlibrary.org. Just drag and drop the TTF file to the project and you are good to go. To find all the text components, write T, text to the hierarchy search bar. Select them all and replace the font. Do the same for the game over and the main menu scenes, and set the text color to black. That's much better. Set it to black on all buttons. Now let's add some kind of story. I imagine that this is an evacuation. So the TV will say, all personnel, proceed to the emergency pods. The keycard will say, keycard, clearance level C. The hidden TV will say pause remaining unknown. And the console will say ladder is lowering, setting the emergency pod. I think it will be enough to trigger the player's imagination. And finally, let's move on to the post-processing. As I mentioned before, it is similar to the Instagram filters. There are a lot of effects and options to tweak, and I won't cover all of them, but only the ones I think will improve our game. Open up the package manager and install the post-processing package. Create a new game object and call it post-processing. Add a post-process volume component. Now select the camera and first turn on the MSAA off. It was causing problems in my project, and we will add anti-aliasing with the post-process anyway. Add the post-process layer and set the layer to hand. It is important that both the camera on which the effects will be applied and the post-process game object are on one of the layers selected in here. You won't see the results otherwise. Select an anti-aliasing mode. All of them produces different results with a different impact on performance. I won't go into the details. Speaking of performance, the post-process effects can be very costly, so use them with caution and frequently test the performance on your target device. Same goes for lights. You may consider baking them for the best performance, but that is a whole other topic. To see what we are doing, switch to the game mode and disable the pause screen game object. Select the post-processing game object and turn on the Is Global option. You could set different post-process effects for different areas of the game, but we won't do that, so global is what we need. Click to the New button to create a new post-processing profile. Unity will automatically create the profile next to the game scene. You can edit the profile directly or from the post-processing game object. The first effect that we are going to use is ambient occlusion. It will make areas with geometry intersections darker. Set intensity to 1 and the mode to scalable ambient obscurance. It should be enough. Keep in mind that we don't want to overdo it. We want the effects to be subtle. Next, add auto exposure. You know how your eyes adapt to the brightness of the light in your surroundings? This effect will do the similar thing. Play with minimum EV to see what I mean. Leave it at -0.5, it should be enough. Next, add bloom and set the intensity to 0.5. Finally, I will add the grain and set its intensity to 0.25. You can play around with other effects as well, but I think this will do just fine. And we are done. Wow, that was quite a journey. Even if you didn't have any idea what Unity engine was before this course, you developed a game from start to finish using it only in a few hours. All there is left to do is build our game and send everyone who has a computer so they can appreciate our hard work. And we will take care of that in the next and final video of this course. See you then! Welcome everyone to the final video of this course. Now that you have a full game on your hands, it is time to build it. Open up the build settings and let's take a look at what we have here. At the top, there is a list of the scenes we want to include to our build. As the application launches, Unity will load the first one. So make sure that the first scene is the main menu. The rest is not that important. In the platform section, you can see all available platforms that you can deploy to. In the beginning, we didn't download any of them, so we can only have PC support. You can always download a package from the Unity Hub and get a build for a different system later. On the right side, there are some platform-specific options. Usually, the default settings are good enough, so I won't go into the details. Click on the player settings and let's take a look at those. At the top, you will see company name, product name, and version fields. Those are pretty self-explanatory. You can set the icon of the game using the default icon field. Similarly, you can change the mouse cursor. Open up the resolution and presentation options. If you want the game to pause whenever it is not the focused window, we can turn off the Run in Background option. If you want to disable the resolution dialog when the game launches, you can do this using this option. Turn off the aspect ratios you don't want to support using these options. You cannot disable the Unity splash screen unless you pay for a license, but you can tweak it. Click on the preview to see the current splash screen. Add as much logos as you want with this list. They will be shown sequentially. You can have a background image as well. There are a lot of optimization options in the other settings, and as usual, I won't go into the details. You can check the documentation, it is pretty good. So finally, open up the build settings window once more, press build, select the folder you would like to get the build to, and wait for Unity to do its magic. Open the folder and play your own 3D video game. Congratulations, you've made it! I hope you've enjoyed the course and did learn a valuable skill. Now that you have learned the basics, it will be much easier for you to move forward. So take care until the next time. Bye!